Yes.
We can check for live. Check the recording.
सब वो क्रोम पे चलेगा, क्रोम पे इसका स्क्रीन शेयर करेंगे, चलाए दे।
चलो
सबसे पहले वही चला, सबसे पहले वही।
ओके, कुछ कोई लोग पूरा रूम भर गया तो उसको चलाने में ये टेस्टिंग के लिए
asked me to tell you a little bit about some of my backstory and what we're doing.
इसको प्रेजेंट कर पाएगा उसको चला कौन है भाई
And I work at the Linux Foundation, and my focus at the Linux Foundation is how what can we do to make embedded systems.
Can someone make this one full screen?
Yeah.
I'm only putting it closer to the wall so that the camera can better take the video. I think the GSOC penalty will skip because we are very late. We start with 8 and then we continue how we.
Then I'll put it this side. You're skipping the GSOC.
What about
but in 20 minutes.
what in 20 minutes?
Each session is in 20 minutes.
What is this? It started all at 10. No, I'm an hour off. It started all at 10. We have now 20 minutes until Kate's session. Yes, we should now. Let's do some. Yes, the schedule. I've here.
20 minutes or 5 minutes?
Yes. I will open the schedule here. That for reference, you can always go over again.
It's 10:45, 5 minutes.
Yes.
Last week, the answer
So, if I want to say something, can someone set up that I can say something? Yes.
Is the receiver connected with this?
What? It is connected with room 1. So if you unmute room 1, one should hear me.
So like room 1 is unmuted already. Like it's on already. You can start speaking. You just need to speak in the microphone. Just use the microphone and speak. Start speaking.
Do you hear me? Anyone on YouTube? Anyone on YouTube here with me?
Till Avi, can you like tilt it?
So let us start. Today is the second day of our nice small conference, and we will start in some minutes with Kate. And she is not here. She could not make it also for a remote talk, and so we have a recording of her, and we'll play it. As we had again some problems with the sound, we are skipping the panel about the Google Summer of Code so that we can continue in time with the rest of the sessions. And yes, and in the end of the day, we have a workshop, the SNAP workshop. Everyone who wants to participate in it should up to then prepare for it, go onto the website of our event, into the timetable, and then click on the entry for the snack panel so that you see its description, and in the description there are instructions. And if you need the virtual machine, come over to me so that I can put it for you on the USB stick. So I think we can now start with Kate's talk.
Thank you, Bill. You can please play Kate's talk.
Avi asked me to tell you a little bit about some of my backstory and what we're doing with the Zephyr project. And so I thought I'd basically take a look at what's going on stably. My name is Kate Stewart, and I work at the Linux Foundation, and my focus at the Linux Foundation is what can we do to make embedded systems be dependable, which means safety, security, reliability, maintainability, things that are essential for us to be able to really depend on using these components. And being able to depend on these components is going to be a key thought here when we talk about what's going on. So a little bit more about me. I've been out in the industry for over 35 years, and basically came out with a master's in computer science from Waterloo, Canada, and have been active in a variety of roles over the years, from working in cloud development to basically looking at, languages and then into the embedded side of it. So I like to begin the hardware, and so Zephyr's been a lovely match for me that way. And then the other thing is, one of the reasons I went into computer science in the first place is I saw the potential in my undergrad, all the different things you can do with it. It was a wonderful tool to help make things better, be it, automating, cancer remote protocols, which is one of my co-op terms, or other things. There's just a lot out there, and there's a lot of really interesting things to work with. So I've actually been actively supporting open source development with the teams I've been working with for over 20 years now. And I have been working with teams in North America and India and China and Europe. So hello to any of the folks that have known it. And most of the work I've been doing has been ranging from very small companies, startups, to very large companies like IBM.
With internet.
Speaker is not on.
As well as, sort of mid-sized ones like, we've seen also now nonprofits like the Lewis Foundation. And so, to this, one of the most exciting projects that we're working on, we also project in 2016.
It's out of battery.
It has been slowly shrinking.
Use this one if it's out of battery.
To it. So we really have to see some pretty exciting things in actually never seen products in December. And some of these products are just near and dear to my heart because I love to love that topic, so I want to see these happen.
One हो गया.
Particular special, help some of these initiatives. Also, gardening and I do a lot at home. I like to hike, travel. So there's tools and techniques. There's tools and products now emerging that are all going to help this stuff. So one of the things I care to do some things differently and be more efficient. How we do things going forward in order to get some of the sustainable, sustainable development goals that the UN's working towards, helping in some of these areas. And so that's most of what we're talking about today. So for those who are familiar with Zephyr, it's an open source real-time operating system. Basically, most of the time, I do work a lot with Linux kernels around their community for like real-time and things like that. But Linux doesn't get slower than a certain amount. And when you start to work with sensors and things need to long power in the field, you really want inject resource constraints. You want something that just uses exactly what you need. And so it was built so that it was going to be able to work with the safety perspective as well as the security perspective. And we've grown a very, developer community. It's very quite extensive. I think we got like over 4,000 on our Discord channel now or something like that. So, like that, there's more information at the end about how to contact, how to engage. But you'll see that it is a fairly large ecosystem now too. There's over 500 boards. So if you've got a board in your head, there's a good chance it might be in Zephyr already. And there's over 100 Zephyr repo. So there's a pretty good chance that you've got some of the current boards that are out there right now. They're probably instances in Zephyr. So you can start to play with it pretty quickly. The project is neutral governance. We basically make sure to know what company dominates. And then we have a wide range of companies participating. That helps fund the project as well as make the infrastructure available for everyone. But we also have obvious dealing with the project too, and and there's a lot of interesting things that are coming up as ideas later and businesses later. It's got permissive licensing, so this is good and bad. The good part is that it's easy for people to use, and you don't have to worry about certain things like patents and so forth because of the contribution terms. The bad thing is, it's hard to find which products are using Zephyr. We've been watching and sort of growing one by one. And luckily some people starting to share with us that they are using Zephyr, and so that's so well. The key thing for Zephyr is to understand it's small. You can pretty much have a world type equivalent, about 8K, or Flash and 5K right now. So, but you can also scale it up. So you can add in drivers, you can add in other information, like other that you can just permit. So anyone's familiar with Linux kernel, okay, and device tree, both of those mechanisms are in Zephyr. And they're being used in Zephyr. So you can pretty much go from these very small sensor to multi-core systems with Zephyr, and have Zephyr working with Linux on another core. All sorts of different configurations are possible. And as I said, to the project to follow the security best practices. It's one of the few open source projects that is in CD memory authority, so we manage our own vulnerabilities. We've got a PSER team that works on keeping an eye on the securities. And the project is going after safety certification. We're going after 61.508 this year, and next year. And so we also have taken the concept of the long-term support kernel from the Linux community. And so we have every 2.5 years roughly, we come up with an LTS for Zephyr where we do all the backdoors and security fixes to it. So this makes it something for products. If you don't need the latest security features, that's stable, but has the security fixes that you also, if you are on the cutting edge, you do the cutting edge until you have the Zephyr, until you get the LTS, and then you can keep your product on that. So different ways of working with the community, different ways of working with the model. We try to be flexible that way. Everything is open source, as I say, and it is a very vibrant ecosystem. Most of the major silicon vendors are supporting us at this point now, and we're also getting a lot of basically product makers now into the community as part of it. And so there's lots of opportunity for various jobs and various innovations to happen out of the Zephyr community. So going forward here, one of the first ones, obviously, is we all want to eat food. And so the 0-100 goal is obviously 1 year and do I think everyone else. And part of that's growing your food. And so with a lot of climate change that's going on and a lot of the issues with water and water shortages and so forth, so we're seeing some of that here in the US and some parts of the US, so certain of the rivers. The IIT soil monitor, basically looking at the soil moisture monitoring and having probes out in field, communicating what the soil moisture is like, so they can determine if it's appropriate to do irrigation at that time or not, and just irrigate when you really need to keep the plants healthy. There's a reference design that is available today that Goliath, which is one of our members, has posted. They also posted a reference design for an IoT greenhouse. And so, that is sitting there. And if you want to start looking and planning on setting up a greenhouse monitoring system and working with the cloud, they've got examples on how to start going in these directions. So these reference designs basically give you sort of starting point to look at these things. But they're there and they're obviously going to be helping with food production in the future. On a more personal local scale, Gardena, we just actually learned about this one in the last 2 weeks. Their irrigation systems, they've got a smart irrigation controller that's running Zephyr to manage, schedules for watering direct regions and so forth, and you can buy this in hardware stores now. So the fact, we're seeing it in the commercial end products for customers' hands, but also, reference designs are able to build more innovation from. So that's up there right now, that I think is, helping with the food supply. And, the light on that one, it's also sort of related to a food supply when you're talking about, herds of cows and sheep and goats, and, horses or whatever, whatever. So there's a livestock tracker that's out there right now that has over 100,000 units deployed for tracking animals. And, basically they're putting on a collar, sort of like the old cow bells. For those who are familiar with putting bells on cows, it's just an electronic version of that. And so that helps you find and locate your animals, and especially in remote areas where you may not have hit fences in there. I know that, like when I was traveling in Mongolia, the herds do not have fences. They're not fenced in, so they're wondering that the shepherds are keeping an eye on them as they travel in the field. And, sometimes if an animal goes missing, the neighbors picking up their cell phone and calling their neighbor on his cell phone to find out if you see my animal type of deal. This type of technology can at least let you basically pinpoint roughly where your animals are and go find much more efficiently as they stray out from the herd. Other things to do trackers, they're starting to emerge, things like, tracking an asset. to make sure that it's, the food is, stays frozen while it's being shipped, or vaccines stay in the proper temperature range. From the things we've been going through recently, we know that that's kind of important. And so there's a reference design for the device, but again, on how to set quality monitoring. Again, this helps with your health. If there's things that there's changes in the environment, you may want to know, and there's certain sensors out there that can tell you this information. It gets aggregated in and work from there. Now, for a personal note, it's a well-known fact that if you can't hear, you don't lose long, because you don't get the stimuli. And so one of our members actually are now using Zephyr underneath inside them. And so communicating with Bluetooth, communicating with other technologies, we have these hearing aids available that Zephyr, and that hopefully will help people be more productive and interacting with their environment and keeping well. And so for those of you who are interested in fitness and monitoring your own fitness, things like that, learn how to watch this. And so it has various sensors for pulse and various health facts like your heart rate and your sleep tracking and various other biometric stuff. And so you can be wearing a nice watch and tracking this type of information. And it's running Zephyr, so as a result, its battery life is long. They highlight that with the battery life. Is enhanced. Usually when you see a product go from a short battery life to a long battery life and nothing else really changes, there's a good chance they might be running Zephyr under the covers now. And then there's Mandi device is now up there for basically emergency alerts. So if you've got like seniors who are finding to stay living on their own and so forth, and having an alert with basically having an emergency button, as well as being able to detect some hazards and things like that. So it's a range of sensors and then provides feedback. And so this is sort of working again with Zephyr under the covers. And the other one that's an interesting one is it's a couple of domains. This is actually the first product we learned in the field that was actually in production. It was several years ago. And they continue to refine it and enhance it, which is kind of cool to see as well. But ProGlove has made these barcode scanners. And when you basically, if you've got a device and you have to keep clicking on it, it's a recipe for repetitive stress. So by having this type of device available, they basically put it into a form so it's much more ergonomically sensible, and it basically just reads the barcodes and sends the information over to server, which is also running Zephyr, and it is basically used in factory floors today as a way of helping to basically help people and also quite frankly improve the infrastructure. So we're hitting into the life on land thoughts is quite frankly, there's a reindeer tracker. So it's an ear tag. It's a very simple little ear tag. That has Zephyr inside it. Well, it has processors and so forth that are running Zephyr and have extended battery life. And they are using it up in Finland right now for tracking reindeer herds. And the reason this is economical to do so is if a wolf pulls down, basically kills a reindeer, the government will reimburse it. But they have to prove evidence it was a wolf. And so this lets them figure out, okay, this reindeer's not living. Okay, where is it? Okay, fine, we can document the fact that it was like a wolf kill or something else. As well as, finding when the herd is, parts of the herd may have disappeared or something. Something's left behind. This is ways of basically identifying what's going on. And it's in production today, it's available today, you can buy it off the shelf. Another animal tracker is like, I guess, for life on, for life on land, size for wildlife. And this is sort of near and dear to my heart in the sense that a lot of species are getting endangered, and there's a lot of, obviously contention between man and animal in space for, space and habitat. And then there's all the story about the poachers. And there's Smart Parks initiative has formed, and there's a product line called Open Collar. And these are being used to track and, monitor wildlife in parks and help make the roam free effectively, but still be able to keep an eye on them. And quite frankly, if a poacher intercepts them, potentially be able to deal with it effectively. And I guess in June, Lucas Mustafa, who is the CEO of Burnouts, gave a keynote from the United Open Source Summit that we had in Prague. And his keynote was basically talking about the implantable devices that they put into the rhino horns so that they could track the rhinos in the field. And it was, he actually, they've actually used these now in the field, and they've actually caught poachers from that. So being able to catch these poachers who are, basically threatening a species with extinction, I think is something that makes me personally very excited and happy to see that we're starting the technologies to enable the under-resourced rangers to what extent to be able to start to track and be able to understand if a rhino, there's a poacher that basically is taking rhino, and can prosecute that poacher and get them off the streets. And that is, I think, that's another nice game changer. And so this is all happening in Africa, and maybe we'll see some of the sort of technologies move to India at some point too. And then on the personal front, I had a dog, and like I've said several dogs over the years, but one of them basically did not like to go to the vet. And if you could jump out the car window when we were on our way to the vet, you would do it. And so sort of finding my dog, when he's jumped out and running away from not wanting to go to the vet, being able to track him would have been very handy. And certainly, if there's now a GPS tracking monitor that you can basically put on the tag for your dog or your cat, and keep an eye on the cat. If the cat is gets out of the house or roams around or gets off property, so you can actually know where your cat or dog really is. And so this one again is another commercial offering that's out there and available. So. By the way, on the bottom of each of these slides, I've put a link to where you can go look for more information on this. Another one I a little bit earlier, but it's also sort of health related too, is the smart pod from Italium. And this is basically a personal protection environment thing that senses a lot of things in the environment for your protection from gases and various other hazards, and then notifies you in some fashion about these hazards that are being detected. And so again, I think this helps with wellness too, as you can tell. If there's hazardous environments, but it also helps with the infrastructure. Another interesting one we learned about last year, actually, we learned about this one, and is the Deutsche Bahn railroad, which is high-speed trains. Basically, they wanted to have a smart pump to pump all the wastewater tanks. Now, I don't know about you guys, but if you've ever been on a train and the bathroom's not working, it's not a pretty thing. And so this is part of making sure the tanks empty properly, so there are some problems on the train when it goes out. And so Deutsche Bahn is using this in production right now with their trains, and it's running Zephyr. Another thing that's not, the shiny and sometimes the very, very practical is the notion of having smart waste baskets. And so this company, Ad Hoc Networks, has created a device that gets mounted on the top of the waste basket and has sensors for determining how full the level is and the status of it, and can send that information through the cloud back to a facility that's monitoring. So the dump trucks can only be can be sent out when they actually need it, as opposed to doing a round, and then most of the time the things are empty, or there's a big party somewhere or a big celebration and the bins are full. They could be notified a bit earlier than their regular scheduled time to go up, clean them out. These are the sorts of things that make our lives a little bit better, and hopefully save some money and energy and save money for the people monitoring, plugging the trash and so forth. So we're seeing some of this now being deployed. There's a case study of it available. And actually, the life also has a use case on how to use that, something like this as a reference design too. From the side of it, it's sort of like you're seeing from those reference designs earlier, but in production right now is this sensor, large vector motion sensing, which is a very small sensor that basically will, it's just like 40 by 40 minute and can be attached to objects and use it for tracking. And it looks at temperature and humidity as well, movement. And so you can assign information and so forth. So this is there, it's up there, off the shelf in the field, and this company is making it, and they're using Zephyr. And another way to learn about this here is basically the solar tracker from Zodec. And as you can see, there's a solar panel on it. So it's basically providing its own power. And it's using for tracking assets, again, like the other trackers, but it has no power with it. And so it can last through a longer periods of time, as well as using, indoor light and as well as exterior light in order to power it. And so tracking, as you can tell, is obviously a something that is resource constrained, and Mandi and Zephyr seems to be fitting into it very nicely. One of the other aspects of this one, of course, is you've got solar panel integrated, is it's obviously going to be good for clean energy. Another thing that's another device that's using Zephyr is, quite frankly, a solid-state circuit breaker. And this is all the program with Zephyr, and it's there to again handle these basically handle these connections. And so the energy infrastructure is starting to really adopt Zephyr, and that's kind of cool to see. And things like circuit breakers are very useful, and other things are very useful, electric grid monitoring. This device here is, designed to sit on these high power clouds, and they're supposed to, we've got these electric disruptors, and over time, integrate. And so these things are doing real-time monitoring. They're doing monitoring of the devices that they're connected to, and they have to last in the field for 10 years. And as you can see, that installing them up is a very big production. So obviously, that you have to have 10-year battery life, and you're setting signals about the status of the resistance on these devices is obviously a challenge. And so this is one of the places we're starting to see Zephyr being used. Another place we're starting to see it being used is, quite frankly, in our lovely, wind turbines. Vestas has been using Zephyr now for several years, and they're not really covered, but yeah, we will basically, if these turbines are there, they're using Zephyr and use it for some of the monitoring and so forth. So these are the different places that you might not expect to see Zephyr because it's so dead. And it's useful for the power constrained spaces, or resource constrained spaces that has to last a long time. Trying to see if it's showing up. Another on the energy sector side is there's like a reference design from the Glyphosate again for the AC power monitor as well as for DC power monitor. And so these are ways that you can go look at seeing how they can be used and doing monitoring in the system. So we'll take a reference and then monitoring it. These designs are really helpful. And another project that's been around for a bit now is the Libra Solar project. It's been using Zephyr for about 3 or 4 years now. And they basically have open source hardware and software for basically setting up microgrids and converting from the solar panels to the battery subsystems and so forth. And so there's reference designs here to play with. It's all using Zephyr. So hopefully that's sort of giving you a bit of a feel for the fact that Zephyr is really enabling a lot of innovation right now, and it's so exciting to see. From animal tracking to asset tracking to wearables to agriculture, healthcare, and energy. These are just a small sliver of all places we're starting to see Zephyr show up. And so I guess my ask for you guys is if you hear of a product using Zephyr, please encourage the product maker to sign up. Basically go to the website and let us know they're using it so that we can basically share some of these stories. It's free for the product makers to put themselves, to put the projects up. And we find it really interesting to see what's coming in, and it kind of makes us feel good about the project to know how people are using it and working from there. So it's it's just a Google form, it's free to fill out. It's just let us know that the products are out there, and we would really appreciate it. And Zephyr wouldn't be possible, quite frankly, without the support from our members. They are the ones that, basically keep the infrastructure going, and, let us run on CI/CD, that's basically health infrastructure. So, as you can see, we've got most of the silicon vendors there, as well as the end customers. Hint, I guess all of these guys have Zephyr teams doing active development. And so when you're looking for your job, if you've been doing some work in Zephyr, they probably have some teams that might, if you want to be working with these guys, as well as a lot of our silver members. And you can sort of see some of the, like the Airnauts folk and the Goliath folk. These are the ones that we're putting these reference examples up there and sharing some of the innovations that they're working on once again small. So if you're interested in participating in Zephyr, there'll be another talk that Benjamin is going to be giving shortly. And I'd encourage you to watch that talk and go into more details of the technology of Zephyr. And obviously links to the project source, and the community pretty much lives on Discord, but there's one mail list as well. And obviously go check out the GitHub vehicle. I will say thank you very much. And looking forward to hopefully seeing some of you showing up in our community.
Thanks, Kate, for the wonderful talk. We would have loved to have you physically present over here, but anyways, maybe next time we can have you. So guys, many of you were there in the Zephyr talks, Zephyr sessions yesterday. So Zephyr team from Hightech and ST company, ST Semiconductors, they have sent some boards. So those early boards are with Akarshan. So we encourage you to use that boards and try to come up with some innovative projects or something you can work around, play around with those boards. And we also encourage you you can write in the Discord channel of Zephyr. Somebody will definitely be there to help you out. And Zephyr is also participating in GSOC for the last 2 years. So this year also hopefully Zephyr will be there in GSOC. So feel free to apply for GSOC Zephyr projects. And of course, like if you need anything, I'm there to help you out. But do go through the talks of Benjamin and Jonas. Jonas gave a nice workshop yesterday. So that will help you out to start your journey in Zephyr. So real boards and the ST boards are pretty easy to use. So hopefully we will get to see some of you contributing to Zephyr down the line. Thank you.
So now next up is Akarshan with talk about scanning, driverless scanning, and his scan application. So Akarshan, where are you?
He's here.
Yes. Could you come to the stage? Could someone put up his slides? So perhaps. Would you go to the screen here? Yes. Are the slides going to StreamYard and not?
Yeah, they are on StreamYard.
Yes. You have put Akashan's slides with StreamYard on the StreamYard collection. Can you make it full screen? So you need to take other slides as well. Yes. Yes. So, okay. Must from here. Yes. Sorry, there was there. You must take this one. Seems to work this way, yes. So let's go now.
So first of all, welcome everyone. You must be knowing me. Bit of introduction about me. I'm Akarshan Kapoor, third year undergraduate in the Department of Data Science, and recently I've been participating in the Google Summer of Code, and my talk got accepted for the Ubuntu Summit. So I will be giving a small talk about what I have done or I'm currently doing in the current Google Summer of Code and how I plan on extending it. So hope you will enjoy it. I will try to keep it from the point of view of a student so that we do not go or delve much into the details so the session gets boring. So it will be a brief overview of the entire topic. So as you all can see, the topic is Scanniverse, driverless scanners, Metascan, and DevOps tools. So first of all, Scanniverse, what do you think from Scanniverse? A scan universe, something like that? We have printing, we have driverless printing enabled. We also have certain scanning tools like Sane and Twain drivers that are available. But creating a Scanniverse or a scanning universe that unifies all of these scanning systems into one is the main objective of this particular program that I am written. So this is the driverless scanning application is the GSOC project that I am writing. I am currently implementing. It will be over by October. And the extension of that particular code is the Metascan part. The Metascan is basically a document archival system that I have created as an extension for this GSOC project. Combined together, along with the DevOps tools like Docker, this will be a combined scanning universe, and which will be presented in the Ubuntu Summit 2023. Okay, so first let's start with the sandbox scanner applications. Sandbox scanner applications. How many of you actually understand how scanning works? Will someone from the audience actually raise their hands and give feedback on how scanning or printing works? Because yesterday we had a session on printing. So if anyone understood that, it would be really nice if you could come ahead and give a brief explanation about how printing works. Anyone? Mohit, Gaurav, anyone? Just a brief introduction about how printing works in general. Achha, fine. I'll explain it myself. So, printing basically works through drivers. You have a specific server and a client. They basically work on IPP or Internet Printing Protocol. So that is how printing works in general. You have drivers installed for all other printer software that have. Apart from that, scanning also works in a similar way, but scanner drivers is one thing that has been a problem since a huge time. We have scanner drivers available using Sane or Twain, but right now we want to implement driverless scanning. What exactly do we mean by driverless? Driverless means that we will not be using any other external software for scanning. You will only be using pre-built software. It will be connecting to all the old scanners, and you will be able to manage scanning on all the operating systems that you have. So that is what basically driverless scanning is. First of all, the printer application framework or the PAPL that already has implemented driverless printing, but driverless scanning is something that I have been implementing in the Google Summer of Code right now. And what we are trying to do is basically work on ESCL connections. ESCL is basically a protocol through which scanning is happening on through the client and server connections. So ESCL is basically a protocol through which driverless scanning is initiated. So what we are essentially trying to do is make a replacement for Twain or Sane, because each of these has its limitations. Each of these will have their own driver interface, which we are trying to avoid, because we do not want, let's suppose a scanner gets old after 10 or 20 years, you should still be able to scan on it using one unified software. That is what essentially is a sandbox scanner application. This whole project is divided into two parts. The first part being the callback functions, how you actually interact with the scanner, the client and server interaction basically. That is the implementation of the callback functions. That is the code which is currently written as a pull request in the PAPL repository. Apart from that, the other part will be focusing on the integration of Sane. Sane is basically Scanner Access Now Easy. Basically, it's an organization that made drivers possible after Twain, because Twain was increasing the number of drivers. Sane limited the number of drivers per device to one image acquisition device. So that is what Sane did. What we are trying to achieve is now completely remove Sane, because Sane has now become sort of insane, because it is like, I'll say, because you still need those drivers to implement scanning. So sandbox and scanner applications is basically driver scanning, implemented in two parts. The first part being the callback functions, how the scanner interacts with the client and the server, and server interactions, and the second part being a retrofit scanner device. So let's suppose you need to implement a driver. So the manufacturer can implement the driver, and that driver can then simply be copy pasted into the retrofit repository of Apple. So you will not need to re-implement the complete architecture of the scanning framework. You have a separate scanning framework. You just copy paste the code of
the scanner driver into a retrofit repository, and voila, everything works. This is what sandbox scanner application is. Apart from that, this was a brief introduction to the scanner application framework. Now I am trying to extend it into Metascan. Now, what exactly is Metascan? Let's suppose we have a scanning system set up, right? We're trying to delve into a scanning universe. So essentially what we're trying to do is create a sort of metadata archival system. So once you connect to a scanner, you automatically have a database that gets initiated. That database then can store all the images that you have scanned, and those images can be accessed through the metadata that was extracted using natural language processing. So first of all, we have the Babel repository. It scans, it initiates the server-client interactions. Apart from that, we have Metascan. So basically, it is right now in the prototype stage. We have implemented all the details. It currently is wrapped in a Python shell. So basically, what we're trying to implement is we have the scanner send the image to the scanner. We have the image on the software. What happens after that is we create a database. The database is created to MySQL and it has been linked through a backend on Flask. Apart from that, the frontend is hosted on React. So when you receive the image, the database is essentially created automatically locally on the server, on the Flask server through MySQL. It will be stored locally on the device. All the images that have been scanned will be processed through OCR, that is optical character recognition. And the metadata, let's suppose you have anything like the passport or the Aadhaar card, the information will again be extracted and it will be stored along with that. So you'll not have to randomly search for images that are actually present somewhere in the system. You just type in your Aadhaar card name or something like related to the passport, or even mention if you know the date, you can mention the date and the scanned image comes up. So this is available as a repository on GitHub. You can go out and check. So this is basically a prototype solution that I have designed along with the Scaniverse, along with the Babel scanner application. Together, I'm trying to combine it. It is currently in the implementation stage, but another aspect of this talk will involve DevOps. How many of you have heard of DevOps? DevOps is basically, okay, a big answer if you can tell something about DevOps. Just a brief. Yeah, sort of like that. So basically DevOps comes after, you have written the code. Basically the production environment is where DevOps is involved. So let's suppose now we have made the scanning software, we have the Metascan ready, everything is integrated. Now we want to mass produce it or give it to all the operating systems that we have. So how do we exactly do that? So first I was thinking about along the snapping the application that we have, snapping Metascan and the scanner application framework, but that would have been too Ubuntu centric or Linux snap distribution centric. So why not extend it to OCI containers? OCI is basically Open Container Initiative. We'll have OCI containers like Docker. So you will essentially be able to wrap the entire software into a box, and that box can be usable anywhere. So think of it like you have a toy is inside the box. You can use a toy anywhere in the world, in space, anywhere, but the toy will keep working irrespective of the environment around it. So we have an application that works on Ubuntu, the Linux distributions. We have an application that works on Windows. We have the same application running on Mac OS as well. So that is how we create a scanning universe. The scanning universe comprises of a complete scanning system, a complete metadata archival system, so you have the data stored properly. Apart from that, we also have Docker, so it can be easily distributed. So that was all from my side. I hope you liked my work. You can go on and check the work links, the Metascan repository, and my currently the pull request. Apart from that, you can connect with me on LinkedIn or send me a message on any social media channels. I'll be there. Thank you. I hope you enjoyed.
Are there any questions about that? Nothing? Everything clear? Are there any?
Why is it named sandbox? I mean, it is sandbox or
Sandbox in the sense basically that you can manipulate the drivers. You will not have to create a separate application related to each and every image acquisition device. So one question was, why is it sandboxed? Sandbox is basically an environment where you can change everything, change the playground, but the application sort of works on this. So sandboxing is basically you update the driver info. Let's suppose the scanner gets sold or you have a new set of drivers. You not need to implement a complete set of applications from scratch. We'll only copy and paste the scanner driver code into the repository, the Apple retrofit repository, and after that everything will be collaborated into one and it will work. So that is why it is sandboxed.
Yes, one thing about sandbox packaging, I will give a talk about this later, about Snap, and in one closed shell, and this way it works on any distro. And also we have security because there are only defined interfaces between the inside and the outside. And for the scanner drivers, we have a scanner application which we put into such a shell so that we can install scanner drivers on any distro to make it easier for the manufacturer, as they supply only one package, a Snap, for example, and users can install on any distro. And this way it gets easier for the manufacturer and for the user to install a driver for a certain scanner. And the scan client can also be in another sandbox, in another Snap, for example, simple scan or meta scan or whatever scan client you prefer. And in that sandbox of the scan client, it is not required to have the scanner drivers again. The scan client communicates by network protocol, ESCL, with the scanner application or directly with a driverless scanner like a modern multifunction device to be able to scan. Any other question? What? So we can now go on with critique. So we come to the next stop now from critique drawing.
Yeah. Hi everyone. So let me share my screen. Okay. Okay. Yeah. So hi everyone. I think everything is clear. You all can see me and see my slides.
yeah, yes.
Okay, thank you so much. So hi everyone, welcome to my talk, The Fundamentals of Effective Technical Writing. I'm Ratik Roy, and I'm very excited to deliver this talk today. So why listen to me about technical writing? So a bit about me. I'm a developer advocate at Loft Labs. I'm a GitHub campus expert. I'm also been very active in the CNC ambassador community, and also I recently became a Google Venkat scholar. So, a bit more about me. I've written more than 120 articles as of now. and these are a couple of companies which I've written for. So if you want to see a lot more extent about the articles and the content I produce, you can see over this link over here. So one of the biggest question is why write? So whenever we start with technical writing, one of the most important thing is to discuss about why you want to write. What are the benefits of writing? So a couple of benefits of writing is like you can express yourself more freely, you can talk to stakeholders and communicate complex ideas in simpler terms. And what does it means to become a technical writer? And how does it make sense to write? It is all about how you can communicate your ideas in a more simpler form to the stakeholders as well as your audience. So, one of the questions is how do you get started? So, you can get started in a couple of ways, but one of the simple ways is to get started with writing an article or blog. There are another ways you can get started as a technical writer. Sometimes it might include documentation, it might include some open source project. We will see a lot about them at the end point. But for me, the approach that worked was I started with writing articles or blogs. So, exercise. So, right now, as this is a session and not a workshop, you can just go back to the slides later on and just ask yourself what motivates you to write. Just take a pen and paper and just focus on why you want to write. The motivation is a very important thing as it helps you to achieve more importance in the sense of more good writing, and that is very helpful. So but if you want to motivate yourself to write, you might have a question what things you can write. So there are a couple of categories of articles that you can generally write. So let's see about them. So, first is in depth guides. So, you might have come across a lot of articles in which there is a lot of depth, a lot of technical knowledge in it. Like it goes around to show how a certain piece of technology works. That is a very good way to write if you have very good understanding upon something. Next is the tutorials. I will recommend tutorial to be one of the best ways to start writing about something because it is very easy and very simple way to show your learning in a very specific way. Next is roundup. Roundup is more about comparing things together and showing how things might add up. And then we have comparison, where you compare different pieces of technology. For example, Kubernetes versus OpenShift, so and something like that. Persuasion is a bit of complicated writing form in which you have to persuade someone on how your technology is good. We will see some examples right now. So, like this is a tutorial. So this is an article about how you can build your clusters, Kubernetes cluster using a open source project called Cluster API. So this provides you step-to-step instructions on how you can build a simple application which is a Kubernetes cluster, using another Kubernetes cluster. Next is a roundup. Roundups are a way, as we discussed, in which we compare different solutions to with different options to form an opinion. So this is an article in which you talk about different managerial tools in which you can manage a bare metal deployment. Then is comparison. As we discuss comparison, it is an objective side-by-side comparison of two technologies. It can be more than two technologies. Here we are discussing about how Kubernetes is comparing with OpenShift. Next is persuasion. Persuasion is opinionated case to solve a specific problem, like how you have solved a specific problem or how your company is approaching a specific problems and what you can learn from that. Last is in-depth guide. So as we talked, in-depth guide is a very good way to show expertise. For example, this was in-depth guide in which monitoring was talked about, the specific part of traces, in which we talked about how technology like monitoring and traces can help you to solve business problems and how you can get more observability with it. So why do types matter and how you can effectively use them? So one of the things exercise which I like to do is to pick a recent article you wrote, and if you have not written any article, just create an article you want to write and focus and put that into the categories we discussed. And then ask yourself, which was the target audience and why did you write it? So this will help you to understand the clarity of what is the audience and why do you write it. And the benefit of that is you can form your ideas and communicate more effectively. For example, an article you are writing for a director and an article you are writing for a student is quite different. So having that clarity and the transparency is quite important because that helps you to communicate ideas more easily. Next is organization. So how can you organize your article in a way that is effective for all the users and all the readers? So this is a quote I like. Writing means organizing your thoughts. If your mind is scattered, your writing is scattered. If your mind is focused, your writing will be clear. So how can you focus your mind? So there are a couple of tricks which I have come to know through my 3 years of writing a lot of articles and a lot of documentations. So this is by focusing and starting with research. So first find couple of articles and the documentation and focus on how the things are working for different users and different writers. Then if it's a tutorial, as tutorial is one of the most simple ways to start writing, I'm focusing over there. Write the code, build a demo application, and make notes of how you are having. Sometimes there is a problem, like if you are reading something, there are some steps which people miss. They are not missing that intentionally. The miss happens when the knowledge is abstracted away. Someone who is building the application or building the project has quite a deep knowledge about the things they are doing, and sometimes they can miss simple steps like creating a secluded environment or a virtual environment. But for a beginner or your target audience, that might not be clear enough. So the thing you can do is to seclude that and include that in your article so that it becomes a more simple through and clear through article for your target audience. Next is outline. So creating an outline has come to be very handy because it creates a thought of process. Before creating an outline, I used to write articles as I wanted to. But the problem was there, I used to miss some sections and then I was required to again reiterate the whole part. So then I started to use outlines. So outline is just like a table of content for your blog or your book, but in a more simpler way. So this is a simple format which I prefer. So first talk about the article what you are writing or the docs, anything works over there. Like talk about which tech you are using, who might be using it, and what are you going to learn. You are as in the target audience. Then focus on the step one, step two, step three. For example, if you are deploying an application on Kubernetes, so first step can be creating the simple Python application. So why are you doing this step? How to do the step, and then doing the step. Then is dockerizing the application or containerizing the application. And third one is creating a cluster. Fourth one can be creating and deploying that application to your cluster. Fifth one can be exposing the port. This is a basic form, and you can expand over there, add more simpler steps, add more complex steps depending upon your target audience. Next is organizational patterns. So there are a couple of organizational patterns which you can form. First is chronological, like how steps are happening. Like for example, the pattern which we show now for the Kubernetes article, we focused on a chronological order in which we were creating things as we want to for the next step. Like without an application, you could not build a Docker file or your Docker image. So this is one of the common ways you can see articles. Second is the importance pattern. So the importance pattern can be thought about in a manner where you deploy your Kubernetes cluster at first because that is the central source of deployment. So without that, you can't do anything, and it can be a complicated step as well if you are doing on bare metals, or if you are a bit simpler if you are using some cloud provider. So then you can focus on how you can build the application and deploy. Then is a problem and solution pattern. This is not so good for tutorials, but for another in-depth guides, this is a very good organizational pattern. For example, if you're writing about some software, how it is solving a issue, you can talk about the problem, like how this issue is affecting. For example, if I take example of cluster API, it is solving an issue where you need to have multi-tenancy on it. So you can have a cluster API which solves the problem of creating clusters using clusters without going to some another dashboard. So talk about the problem, then the solution. Last one is ranked order. So ranked order is a bit more complicated pattern in which you rank the order of importance, but with a twist of having more efficiency in it. So if you are a beginner, I will recommend not to going through with ranked orders, but focusing on the first three only. Next is, as we talked about, chronological order. So first you start with the beginning, then the middle, and the end. Talk about how things started, talk about how thing is met, and how it is ending. Importance, as we talked about, just starting with the foundation and going to the abstraction. Problem is like first analyzing the problem, identify solution, choosing solution, plan of action, implementing and differentiating the problem. So this is a like continuous loop in which you can create articles, and it is a very good approach. And last one is ranked order, in which you ranked using best. It is suited for comparison pieces when you rank the best and then go out and then at the end talk about your opinions. One of the most important things in articles that I've written is focusing on introductions and conclusions. So why you should focus on introduction? So the purpose of introduction is the focus on introduction is so that you can focus on how you can get the attention of your user. Having a good introduction is very important because it grabs the attention of users and your readers and makes them stick around till the end. So, and the conclusions are where you can summarize your thought processes and your ideas at the end. So how you can write good ones? So let's go through some examples to understand how to write good one. So for example, if you are building a Nest.js application, so this is one of the simple introductions. Hi, this is my tutorial for building your Next.js application. This is okay-ish, but we can do better. So here you talk about in this tutorial, you will solve and how you will do X, Y, Z. This is also quite better than the last one, but we can do more good. So better is focusing on the problem statement and then showing how you can have. So if you read this, I will give you a minute. It talks about how you can, like why Nest.js is important and then how you can use it. And in this tutorial, what you will build. And this is one of the best where you provide some more context to the user. Here you can see you have provided more context about a lot more things about how things are working, and then showing that how Nest.js is so important and helps you solve the specific problem. And lastly, you can just say about how and what you are doing in the article. This catches the attention of the user very well and helps you to focus on the value you can provide to the user and your readers. Lastly, conclusion are a way to summarize good ideas as we talked about. So let's see some examples. This again, this is a quite a good example, but that doesn't look so good. If you are reading an article, the last line should not be so simple. You should have a reflection of what you have learned. This is also a good example in which you learn about how you build your first API and all those things. Uh, but then there is no context about what you are learning and to refresh. This is a more better tutorial in which you talk about more validation and what you have learned and everything. But we can do a bit better by saying what you have already done over here. Like for example, the first line talks about how easy it is and how you can do this, and talks about more sources where the user can learn a bit more if they are interested. Uh, if you have picked a recent article, you can go through this exercise. So to improve your articles, first is pick that article. This is kind of an exercise which you can do after the events if you are more interested in improving your writing skills. So just focus on the article, pick up the article, focus on the hook part, like where the users can get the attention captivated in the introduction. Then focus on the core topics in the body and focus on how you can improve the introduction. So next section is refining your writing. So focusing on the first and the last part is quite good in having a good experience, but what makes it better is if you refine your writing in a way that keeps your audience attention throughout. So that is what refining your articles means. And so why do you want to refine your article? As we talked about, it is all about how you can captivate the attention and make them worthwhile their time invested by giving them a very good value. So as we talk, is it consistency, quality? You will get more work, more clients, and better reputation. If you're writing an article that is good, you will be reputed and you will be admired both by your internal stakeholders as well as external audiences. So how do you do this? So this is a bit overwhelming, I understand, but it is very simple actually. So this is a self-edit process in which you first organize the article structurally and then focus on the way if there is some issues in the technical knowledge. Then you deep dive into more smaller sentences and paragraphs and focus if they are looking good and if they are breaking nicely. And lastly, focus on spelling and grammar and punctuations, all those things. You can use Grammarly. I use Grammarly, and you can use another open source editors to improve your editing skills, or you can send to your friends so that they can give a look. One of the tips I can recommend is to write reading the article next day so that you focus a bit more about learning. Uh, Also, it's very important to link to academic researchers surveys and other articles so that you can show and prove your points, because in technical writing proving your points is very important. Like suppose you are claiming that this solution says 30% more CPU and bandwidth, then you should have a research paper or a simple research which you do with the help of benchmarking tools to prove that, or else the trust is not gained inside technical articles. And the next is a lot of things a lot of times there is the why missing, why you are doing this, why are you using this tool. So focusing on why is very important. Like if you see in the gray area, it shows why you need the passport package. It is because it provides authentication provider and supports multiple authentication provider. So providing why gives the user more context and helps them to relate more. And one of the most important things I want to talk about is scannability. The article, the side on the left is very like you don't want to read it even if you want to. But if you focus on the right, it is so simple. Like you can read paragraph after paragraph after paragraph. That provides you and the reader a smoother experience. So, if you want to do exercise about the things you did, pick up an article, self-edit, prove every point, and focus on answering the why, as we talked about, and then make it a bit simpler by breaking it into paragraphs and breaking into sentences. So, to focus on why write, like you can write because it helps you to clear ideas, and then there are type of articles which you have seen and helps you to structureize your articles and organize. Focus on your introduction and conclusion, as it helps you to focus on the complete part, and then refine your article so that you have a bigger picture. But start with focusing why you want to write, or else it becomes quite hard. Some motivations can be you are writing to simplify your learning, you are writing to earn money, you are writing to communicate ideas to stakeholders, you are writing to solve a problem which you are facing. So after writing, what you can do? So I have a couple of friends who have done a couple of things. So you can do internships in technical writer roles in DevRel Dev, in which writing is a very good way to get in. Then there is freelancing. The articles and the clients which I saw in the second picture was example of my freelancing. And there are a couple of good programs like Google Summer of DOS, Google Summer of Code, Linux Foundation mentorship programs in which you can apply and get into the programs and focus on improving your technical writing skills. Last but not least, thank you for attending my talk. This is a QR code in which you can connect with me and ask me other questions if you have any. So feel free to connect with me and shoot your questions if you have any. And you can download the slide deck from the event website. And please feel free to ping me if you have any questions around technical writing. Yeah, I'm open to any other questions. So please feel free to push them.
Anyone has any questions?
Hello, am I audible?
Yeah.
My question is, how does the field of AI affect the field of content writing and its future? How will I prove myself to be better than an artificial intelligence tool?
Yeah, so the current limitation of AI is it writes good article, but it writes good article on things that are already it is trained on. Like there is a cutoff date of 2021 for Chat GPT, as I'm aware. So uh, the requirement for technical writings at the moment is areas where you are creating original content. AI can create content which is already written very well, like suppose you are comparing some pieces, but sometimes it misses mark where technical knowledge is required, like how exactly things are comparing or what is the efficiency percentage of how things are comparing. So there is a mark where it misses, and secondly it misses on a part where you write original documentation or original stuff. So previously, a lot of people used to write simple pieces in which there was no originality. But what AI is doing is to make us more original and make our focus more into writing content that is original and more technical. So if I want to say a simple summary, I will recommend focusing on more technical skills so that you can understand things more thoroughly, and then creating content on your understanding. That is something which is very much in demand in the industry right now. But simple pieces like what is a Docker, what is Kubernetes are getting back because you can ask them, and that is not something very important. But focusing right how you can deploy this project with XYZ is quite popular. So any other questions?
Did, did he answer your question well?
Yes.
Any other questions? No other questions? So then we have done our pre-lunch part of the conference today. So we will see us after lunch. So
Okay, thank you
wait
so much
hour.
for having me. It was nice to present the talk over here. Thanks still for having me. Bye bye, everyone.
Thank you very much. Thank you very much. So this
Schedule a break in which
one thing is you take out the camera image so that you see only the raw data.
So remove the podium.
put the home camera in. And we need also the slides, which they put together. We have one thing, we have 2 slots for spontaneous lightning talks. And so if any one of you has something to talk about and wants to give a 5-minute lightning talk, please tell us and when we can put you in. Yes, yes. Can you put in the slides? And can you go full screen? Yes. So, the stages.
Hello everyone. This is going to be a slightly interactive kind of a talk. So if you can come ahead and sit, I'll be able to hear your answers. And it'll be simple, don't worry. There's nothing complicated happening here. But we would really like to get the people ahead so that I can at least hear something. Hello everyone there. Yeah, it's fine. Okay, so while you settle down, I'll probably just give you a quick introduction. Some of you might know me from the last few days. I'm Nipul. I work for Canonical as a technical author. I started out like y'all, computer science, BTech and MS, and well, later on I happened to do a few other degrees too. But so mainly I was a software engineer, an embedded engineer. In between, I was a visiting scientist at CDAC for some reason. I became a prof for a few years. That was fun. And later, I also became a patent attorney, a system admin, an operations head. And you basically get the idea that I like to try out different things. And it's fun for me. So, and yeah, I've got the backing for it. I became a patent attorney because I've done a law degree. And I became an operations head because I've got an MBA degree. So it's not totally weird, but it's fun. So I kind of try to do things for fun. And now I'm a technical author. So this is new for me. I joined in Jan. And I want to see if this is fun. And I want to see if y'all can find it to be fun. So, okay. So all of my previous jobs, there was some sort of documentation involved. It's quite obvious. If you're coding, there is documentation. If you're creating a product, there's product documentation. If you're a lawyer, there are contracts involved. So if you're teaching, there are notes involved. So everywhere there was some sort of documentation, but none of it is really disciplined, or there is, it is not very concrete. It's all sort of in the air. You do your best and you see what happens with it. So the idea here in Canonical is we have this director called Daniel Rosiga, who's our director for the engineering director for the documentation practice. And we want to come up with this really good, disciplined, good documentation practice, which hopefully will spread not just in Canonical, which is kind of quite big, but also across the industry. Because currently the documentation scene in the industry is pretty bad. So if you are going to search for something, you usually search, you just open up Google and that's it. You don't really go to the documentation of a particular product unless it's really good, maybe Python documentation or something of that sort. So the idea is to make it really good, and that's the process that we are starting. And it is not easy. Believe me, it is not easy. It is a challenging problem. Just to get people to read the documentation is a big challenge. So, so let's see if we can solve that problem, and in the process, if this challenging problem is fine. So, I'll have to look it up. Okay. So, starting off, we need to understand what it is. Can you give me some off the top of your head? What do you think documentation could be? Anything? What is it? Types of documentation.
Sort of manual to use some product.
Yes, manual to use a product. User manual. API documentation. Cool. Anything else?
Getting started.
Getting started guide. Yes. Anything else?
Tutorials.
What's new? Yes.
Tutorials.
Tutorials. Nice. Anything else? Cool. So, so in fact, you have got the right picture of what technical documentation is. What about, I mean, so this is because initially when I joined, I had a few computers. So what about things like blogs? They could also be technical, or marketing material. They also describe the product, and they can be technical, or videos. So, or contract, or what is the license being used in a product? So all of this is still we are looking for. So, so just to get a clear picture of what, yeah, sure, thank you so much. Okay, so here I've just put in these random things. Some of these you come up with user manual, getting started guides, and API documentation, and lots of even code documentation, and then the feature lists, the comments. All of this could be some sort of documentation, but then what is product documentation? And what are these other things? So if you just go ahead, yeah. So the things on the left here are the inclusions in product documentation. So, maybe if you have come across any actual documentation, let's say,
so that she always stays in the picture.
If you have good product and it's good documentation, you get a feel of what I mean here. So everything that you would think is technical and let's say not marketing jargon or not trying to sell things but to actually give information out, all of that will come in here.
But not do not,
and that's what we're
not
going to try and focus on. That's our very problem. Okay.
So that you can see the
okay. Anything here that you find funny or you don't understand here in this list?
What?
You can take a few.
Yes.
Yeah, this list is just to give you an idea of what could be. It seems fine, right? Standard operating procedures are maybe, if it's a lab and there's a specific process to be followed to execute something. So that's again specific documentation. It's a list of steps, you have to follow that. And then, so that's all included in documentation. And what's excluded is code documentation. So would we be in that website, which is actually your product's documentation, would you include code comments? No, right, that's part of the code. So it is why that won't come in there. Or if there is some marketing material, that is not really technical documentation, that's a different thing. So all of those things there, what is the license? And then there are some videos about it on YouTube. So videos could be used as maybe tutorial material, but it's for general videos, we keep it out of it. Okay, so all of those contracts, facts, all of those things are not what we are currently considering. What you're looking at is this. And so that is our definition of what is documentation. Now we go ahead and try to see how we do it. So before how we do it, the most important thing, why is it needed? And then we get to how to do it well. So anything that you want to do, always go start with why. And that gives you a nice start of path to how to go about something. So question, why do we need a documentation? Exactly, you don't know how to use something, you don't know the API unless you have it in front of you, how you use it. So the basic thing is people need information. It's as simple as that. They need that information and your documentation will provide that. And people and information, this is all there is to it. Okay, so we will concentrate on this, try to figure out what people need and what information needs, and based on that, come up with some solution which will hopefully work. Okay, so how do we do it? Well, we think about the people first. That's right. Okay. So, let's take one. Just show me the picture of that. Yeah, thank you. So we are considering a product, just for simplicity's sake, and since the slides already had this as a product, I'm going to use this as a product. So this is a laptop. Think of this laptop and think of what sort of people can be involved with this product. First, just with the product, what sort of people will be involved if they want to use documentation. So, in terms of you all use laptops, so of course you all are users. And now, from the documentation perspective, are you all users? And if so, yes. Okay. Is there any other? Okay. Is there anything else that you would? Okay, let's just show me the next one. So the first one, product user, that's you using the laptop. Anyone who uses the product is definitely someone who might need to use the documentation. Unless you are born with knowing everything about the laptop in the world, you might have to go and figure out how things work. Okay? Second, some of you all, I'm sure, are developing new things. Some of you all are in TSOC and all, of course, you're developing new features and stuff. So you are beyond the user of a laptop. You're maybe in the next version of the laptop, there's a new driver coming in, so you want to support that, or you want to support a new external hard drive or whatever. So if you're a developer, you're a different type of a user for that same laptop. And finally, last one, any difference? Why is there buyer separately there? Is a buyer different from the first two?
Or it is already has that he's using it correctly. And buyer it does not have it, he is deciding to decide whether to use it.
Yeah. So buyer is someone who does not have it and who has to decide whether to buy it or not. So hopefully in your case, it's your personal laptop, you are the buyer, you decide. But think of a big company and they want to give laptops to everyone in the world. Sorry, not everyone in the world, everyone in the company. So they need to decide about what sort of laptops to buy, what is the configuration. They'll be thinking not about what drivers are there, but what are the different things that my people are going to do? What is the memory that is needed, or what are the connectivities? What is the security that's implied, that's needed for the laptops that they're going to buy? So all three of them are users, and they have kind of different needs in terms of information about the laptop. Okay, now that's all about the users. We are talking about documentation, and there's this other set of people that we need to consider, especially people like me who are going to do the documentation. So if you realize, in general, documentation is a pretty kind of difficult and tedious job, and it'll be nice to make things easier for the person who's creating the documentation. So if we can go ahead. The creators of the documentation, who are they? They are people who actually build stuff. So the engineers who are making stuff, they write documentation for it. The technical writers who help them make it better, more correct, and more user-friendly, easy for the person to read. That's the technical writers, and finally they're managers. So we want to try and make it easy for these people. And one more last thing, let's go ahead. Oh yeah, okay, before that. So how do we make it easy for them? First thing, let's see how do we make it easy for the reader. Who's the reader? Reader is the user, basically, all the first three things that we saw. So what should it be? It's written there, but otherwise also, if you want to, what do you think as a user the documentation should feel like, or would it be nice to have?
Should be more graphical. It's easy to understand.
It should be easy to understand. Graphical is an option.
Descriptive.
Descriptive, okay.
Visually appealing.
Visually appealing. Short and sweet.
Like explicitly.
Like explicitly, cool. Okay. Anything else?
With good examples.
With good examples, nice. Anything else?
Mentioning prerequisites.
Sorry,
Mentioning prerequisites.
mentioning prerequisites.
Should not require another documentation to understand.
Yes, you don't need another documentation to understand this documentation. Okay. So all of these. So in fact, okay, yeah, we'll come to that. So that's good. So that's all that the user wants. Okay, so we want to make this documentation easy to understand, it's nice and appealing. We consider each of these things. Okay, it has to be all of this. So all of these are constraints for our problem. Okay. Now we look at the writer part. Writer is the one who's creating the documentation. So what are his problems? Sorry? Too much manual work, yes. If we can automate things, especially simple things like spellings or grammar or there are so many, or there is API documentation, and if it can be automatically generated as the code is written, then things become a lot simple for it. There are these menial tasks that is difficult. You want to remove all of that. Anything else? Let's start with there. Knowledge of the whole code base.
Like if I'm writing it for an API, I need to know the workings of the API right now. So I need knowledge of all of the API. So better than still it's a part of manual.
Yes. So yeah. So if you are going to write, you have to know it really well. So there is no question about it. That's why they are called technical authors. In fact, they are an authority on whatever they are writing about. So yes, there's no real getting around that. You have to understand it and you have to do that. But what we can do is simplify things by, if there is API for instance, and if there is a document generator, API document generator, it's definitely easier because there will be less errors. So even if that person knows it, instead of sitting and writing it, if it's automatically generated, we hope there will be less errors. Okay? And of course there's tooling. So tooling is also important. It's not the end of the world, but it's useful and important because it helps you manage your code. So helps you maintain it. So usually docs code is used. You basically put documentation in a GitHub repository, and as your product progresses, new features come in. Along with it, its documentation is generated. So your documentation has versioning and everything. So and your engineers are happy because they are used to that. So that's what is good for them. And the main idea is to minimize the decision making for writers. So your questions like, should I use which sure or that? Or should I use the UK spelling or the American spelling? Or is this word fine? Is it woke? Or am I allowed to use master slave? Or is slave no longer allowed? So there are a lot of such questions that is not very obvious and that is unnecessarily time consuming. So these things can again be taken out of the workflow, automated. There are checkers available for this, and there needs to help them. Okay, so that's how we're going to help the writers. Now, one last thing that we will consider is information. So people need information. I said we'll be looking at both people and information to just come up with the problem and the solution. Now, information. What does it need? Let's see the first one. Okay. Any idea what constraints information puts in there? How should information be presented? Is that something that you have to decide? Should be concise.
We got the right trade-off between too complex and too simple.
Yes, the right. What did you say?
Trade-off, like you need to not too complex, not too simple.
Not too complex, not too simple. Yes. You need to get you need to get things right. That's like very. Yeah, that's really important, and it's not very easy to do. But yes. So the information architecture is deciding where the information will go and so on. So that's one big part about information. And there's also, if you want to maintain the information, how do you do it? Does the information become obsolete? And if so, how do you keep track of it? You need some processes for that. Okay? And when you're saying, you mentioned things like of course, there are things like they should be correct. But it should be concise, and even if things are correct and concise, they should be useful. You just don't write stuff which is never going to be used, or you don't write wrong stuff. So there are some basic functional quality requirements. Those are these. They need to be accurate, precise, but you also need something called as deep quality. That's what it's not very obvious what deep quality is. But if you really enjoy something, it is, then you realize that has got deep quality. So, for instance, if you're reading something and then you suddenly think, oh, but what do you mean here? Or, but how does this happen? And the next statement literally answers that. You feel so cool, oh yeah, wow. So, there's a nice flow to it, and there is that deep quality to it. So it's like if you have that sort of deep quality, you will actually use it. It's for users. So let's say in 2000 when Google basically came out, at that time it was new, search engines were new, and we used to call Google God because you could ask it anything and it would just give you the result. And it's now become so obvious and so day to day, and it's because it's so easy and everyone wants to. You don't even have to think about it. Similarly, if the documentation is really good, you will use it. You don't have to force the user to use it or do stuff to it. It's just good enough, it's useful, that is why they will use it. So that's what your clients strive for. So now these are the things that is basically our constraints in creating a problem. So the use for the user, things have to be easy to use, easy to find, easy to understand. For a creator, the tooling has to be in place, automation should be there, and minimal decisions. He can do things, he or she can do things really quickly, easily. And from the information perspective, information needs to have some architecture which ensures that you put things in the right places and it's easy. It has to have quality, and how do we maintain it? So these are some of the things, and we need a solution which will actually cater to all of this, something that fits in right in the middle there. And we try to see if we can come up with something like that. So how do we solve this problem? So like I said, think of the why, and that's where you get the initial. So here our why was that people need information. It's for them that they're doing things. So we will look at what they really need. We look at the user journey. So, first thing is, of course, anywhere it's the interaction. You need to know what the product is, what are its features, how to use it, what's the prerequisites, and so on. So that's like the basic, and that will be there right at the beginning somewhere. That's not even an issue. The next thing, let's say it's a new thing, and first thing the user does with it. You got your laptop, first thing, what do you do?
First look at the manual, open it.
Wow, he actually looks at the manual. I didn't think anyone in this generation actually looks at the manual for anything. Nowadays, we just go ahead and try stuff. So, but yes. So initially, what you do, you might not know about things. So you want to learn it. How do I use this thing? Now, laptops are really something very common for us. So we need, and they are pretty well developed that you can intuitively do things. But usually what you would do is you start learning what it is and how to use it. So there's this basic thing about installing it and configuring it. So you need a tutorial there. You need someone to tell you, okay, teach you that this what it is and this is how you start using it. So that's the initial trial. Then you decide, oh, good, now I know how to use it. I want to add stuff. I want to add this add-on, and I want to add this extra driver, and I want to, this screen is not working, how do I solve this network problem? Here you go. So there are these problems that come in, and you want to solve them. So that is a different requirement. That's like, okay, these are the problems that I want to solve, and I want documentation for that. Okay. Next, going further ahead, what else could you do? You know how to use it, and you have problems, you started solving the problems. But if you want to go beyond that, is there anything else that you would need documentation for? Sorry, customization, very good. So, he wants to add new features, or he wants to try, there you go. So you want to add new features, you want to use it in a new way, or you want to change the product to make it run in a different way. You want to solve low-level problems in parts. You want really in-depth technical details. Only then you can go ahead and actually do stuff with it, new stuff. You want to contribute to it. So that's a next level of information that you need. And finally, a last level, leisure activity. Will someone actually read documentation as a leisure activity? No, he says no. He says no. No. No one really seems to think that it's a leisure activity. Well, I'm sure there are geeks here who would, if not here, many around the world who would want to know, oh, why was this designed this way? And, or, I mean, you just want to understand things. You want to like, why, when did this start? What was the root of this? How old is this? Of course, we keep watching YouTube videos and stuff like that. So, just to understand who came up with this product and so on. So, all of that, just easy reading stuff, just understanding stuff. But it is not really, it's not serving any actual work purpose, it is more mainly just study purpose. That's what I'm calling leisure activity. Now, these are pretty much all the things that a user will do in terms of documentation, what he needs. So let's try and categorize them. So introduction, I've removed that because I will definitely come at the beginning somewhere. You need to know that. Now, first one. So the first thing was initial trials, and that's a learning thing. So you could call them tutorials. Make sense? Yes? Okay. So that's initial learning, call them tutorials. So second one, let's just read them and then change. Yeah. So here, you're doing problem solving, doing additional steps. You need, so what you need is how to guide. Make sense? So how to guide will give you this list of things. You know my driver is not working. Then it will give you a list of, okay, these are the troubleshooting steps. How to check. You put something in Google, how to do it. They will give you a little list of steps. So your application should basically have something like that. For every problem that the user might come up with, he should have how to guide. What about making actual changes? The real technical detail, the API documentation and all of that. We can put that into a category. Yeah. So that's called the reference section because there's a lot of detail. Think of API documentation. Is that a tutorial or is that a how-to guide? So what is it? It's just a lot of information, right? But it is important information. It needs to be there somewhere. So it's a reference. It's information oriented and it's reference. And finally, the last one. It's just explanation. Things that you just want to understand. So that's understanding oriented and that's explanation. So yeah, good. Okay. So now we have these 4 categories of information. And this is what we will develop this a little bit more. And this is what will hopefully give us what we want. Now look at these. We're going to see if there's something that we can do with this. Let's say. So tutorials and how-to guides. Do you see some real difference between them or are they similar in some sense? Is it confusing? Not really, okay. No? Okay. Okay. Let's see. That's really good. That probably means that I did a good job of explaining this. But okay. So one easy way of if you look at some piece of information and you want to decide whether it's a tutorial or a how-to guide, one easy way of looking at it is, does it serve study or does it serve your work? So when you're learning something new, you're studying, then it's a tutorial. And when you're actually solving a problem, it's for your work, you want to get that done. So in that case, it becomes a how-to guide. And similarly, for explanation, it's just for study, it's just for fun. So that's the study part. Whereas references, you need API documentation only because you want to actually use it somewhere. It's your work. So that is how it's just a way to, you'll see it soon enough why this helps. Now if you get the vertical aspect, The top two things are basically steps. So practical things that you actually do. And the bottom has tutorials and how to guide. And the bottom two things, they're theoretical, right? They're all written stuff, and you're not really doing steps when you are using the documentation, you're just reading stuff. So this whole thing is called the direct access approach paradigm, or it's something that our director has come up with. It's his own theory, and now it's being used in many industries, many companies, and it's being tried out, and we are getting a lot of positive response for it. And I'll try to show you how because we know what the problems are, and we'll see if this will help solve some of those problems. So the first thing is, of course, trying to make it simpler for the user, and we developed this whole thing right now, thinking from the user's point of view, right? And so now if you are the user and you know this is a problem and I need to solve, you directly go to the how-to guides. Or if you're just having fun, you directly go on explanation. I just want to know how this works. So you clearly know where you want to go in the documentation. From the user's point of view, it's easy. Oh yeah, okay. I don't have to search for stuff. I know where, at least at a high level, where I have to go and search. That's the user. We had user, creator, and information. So let's look at creator next. So does it help the creator too? Right. So creator is the one who's writing, and he has to create all this documentation. How does he do that? So he gets this information, and he needs to know, oh, where should I put it in one of these four? So the answer is, this direct access thing gives you a compass, but it makes it simple. Just look at the first one and you say, are these practical steps or is it some theoretical knowledge? Okay, practical steps, then you know, okay, it's just, it has to be either tutorials or how-to guides. And so how do you decide whether it's a tutorial or how-to guide? Yeah, whether you're studying or work. Similarly, once you know it's just theoretical knowledge, how do you decide whether it's references or explanation? Same thing, study or work. So it's a very easy way to, oh yeah, I got this information, this theoretical, practical, study, work, and I clearly know I just have to put it in here. Okay, so that gives a nice, simple information architecture where you know, okay, this is where you have to put it. Now there's another thing this approach actually helps in for the creator itself, which is slightly unintuitive and funny. So usually when you think of documentation, it's like this really big pain. You need to plan a lot of things, and you do a lot of things somewhere and do a lot of stuff. But in this approach, it's much simpler way to do things. So if you go ahead, okay. Before I go ahead, let's do a little bit of examples. Quick examples for you to solve so that we get a feel of this. Okay, first one. An article that teaches you how to use Inkscape. Inkscape is this UI, UX. Okay. So it teaches you. So what is it? Okay, four things. Okay. Next one, an API documentation for microservice. Reference, next. Instructions for updating and writing. Okay, next. Rationale behind using certain UI explanation. And steps to set up your VPN. Okay, cool. You all have become really good at this. So that's how easy things become. Okay, for the writer. Now, this way. And what I was talking about, how to make this workflow for the creator simple. So the idea is just pick up something. Anything that's there in you want to work with documentation, it's already there or it's something that you want to start. You just pick something up, consider it, and decide what you want to do with it, and go ahead and do it. It could be anything small. It could be, oh, there's a grammatical mistake here, or this command is wrong, or this code doesn't look good. It could be anything as small as that, whatever. So all you have to do is just quickly do it and then iterate the whole process. So just keep doing this. And this does not need a lot of planning, and it actually gets a lot of work done. So it removes a lot of it's a little difficult if you, especially in documentation, if you do a lot of planning, things don't really work that way and things keep changing a lot. Whereas if you do this, there is constant improvement. You see that happening literally right in front of you, and those small changes are immediately visible, and you can publish it. And yes, in fact, you should always, whatever you have, just complete that bit and publish it. Never wait for it to become this grand thing, because it will never finish. One thing is it keeps changing, and the other thing is there will always be a better way to do it. So if you wait, you will wait forever, and there's no point in that. So the idea is to do a little bit, finish it, and publish it. So, and you do this with anything that you want to do, and it gives you a workflow that is iterative and it is simple. So it makes the creator's life easy. So now, bringing it all together, let's consider the problem again. So this was our initial problem. And our approach, let's see if the solution to this problem, what we have come up with, the data access thing, okay, is that we're going to solve this. So, user point of view, well, we came up hopefully with all the user journey and the user cycle, and we have tried to address all of those things. So hopefully, because it's such a user-oriented approach to things, it will make things easier for the user. Creator, we just saw how his workflow becomes simpler. There are minimal decisions to take. So at least the minimal decisions part for the creator is something that this approach helps with. Tooling and automation, well, data access does not stop you from creating new tooling and doing automations. So it's not going to create any problems in that sense, and that is something separate you anyway have to do. Information architecture, this whole thing is basically a simple information architecture. You know what goes where. Quality. So quality is a little basic quality about functional quality that I mentioned, which is like correctness and usefulness and preciseness, completeness, all of this. That you have to take care. There's no going around that, and without that, you can't even think of the deep quality. But that is a given. You have to work on that. But this approach also helps towards this deep quality, because it gives you a flow, and it's a little difficult. In fact, it tells you certain things that when things don't fit in this approach, or if there are problems, then you realize, oh, there is a problem, and it helps you come up with, oh, quality is not that good. So it's a little difficult there, but yeah, it does help in quality, and maybe with examples, we'll finally get to a point where it becomes better. So in terms of, and maintenance is again something we have to do. It's a process thing. When do you do, how do you do it, and so on. Data access is not going to come in the way of that process. So our solution does cater to many of, or to at least quite a few of the things, the important things for the problem. Now, last question. I'm not sure. Yeah, I think I'm just on that. Last question is the main question that we've been looking at. Is all of this fun? Is documentation fun? So, yeah, it's challenging, and anything that's challenging is usually in some sense fun. You all are at least IIT students, so probably that makes some sense to you all. So yeah, it's a difficult problem to solve, and there are many things to do with it. So in that sense, it is fun. But if you go ahead, some of the things that's there in this. So there are a lot of things that we as technical authors do, or as part of documentation, you need to write. So there's coding involved, there's automation, you're questioning things, you're questioning assumptions, of course you're testing the product, you're always looking for corner cases. And there's creativity involved when you want to think from the user's perspective and give him the easiest way to understand something. You want to look at, you're actually helping people do stuff. And you get these quick results. And there are constant improvements. Even if there's a problem, it's not really a problem because you can go ahead and make it correct again. You can do that improvement again. And there's no big issues. This is a little, this particularly for me, I used to be a technical delivery manager. So for some SaaS product, and sorry. Okay. And so a client requirements are not good. He can get pretty troublesome. So people issues are not very easy to solve. So in this job, people issues are very, very, very less, almost zero. So that's one more good thing. That's also why, and still you get to work with a lot of people. You work with many teams. So you enjoy working with people, but without the real pain of them asking random, weird questions and which don't have answers and which deadlines that don't make sense and so on. So of all of this, and of course you get domain expertise, which is pretty cool. I mean, I really like to learn new stuff. So all of this definitely creates a sort of a job, a thing that I really find fun. If you all find it fun, then please come and join Apply Economical. We are expanding our group quite a bit. We want a lot of technical authors who are curious and who really want to do something, who are interested and passionate and so on and so forth. If you find any of this fun, apply and we talk. And that's my talk on documentation. Any questions?
Anyone has any question about documentation? Yeah. So,
so my question is like, how can you make
say most engineering workflows, people usually skip documentation, and is people consider documentation as a hurdle and as a part of a workflow. So how do you tackle that problem? How do you make it easier and people want to document things rather than avoid it?
Yeah, I know that's a big problem. So partly, that's kind of what I was trying to say here, trying to make it easier for the writer. But, so in fact, yes, all of these engineers, if you make these things simple for them, that they don't really have to bother about the language, the wokeness of it, the language to use, the grammar, the spelling, and all of that. They know what they're doing, and all they have to do is just write it out, and the rest of the things get taken care of. It does help, but that's not really enough. So in Canonical, at least, we are slowly developing this culture that, in fact, it's becoming. It started off as, yeah, we just want to do this because documentation really helps, and without that, the product does not get sold. People can't use it. So without good documentation, just creating a good product does not help. So we know that it is needed, but putting that across there and then telling them that this is not just a chore, but actually a discipline. It's like programming. You have it's important enough, and it is a discipline in itself. We have kind of created this culture where people have started talking about documentation and they do stuff, and then in every sprint, each team comes up with, oh, this is what we have done. And once people start doing it, there is peer pressure and the other teams start doing it. And soon everyone is getting into that mode of, oh yeah, how do we do this well? And oh yeah, we do this. And documentation is one of the important things. Mark looks at it. I mean, Mark is our CEO. So he said that is one of our requirements. So we have these milestones in your documentation. What are the things that you have to do? But so there is some process-related pressures coming from the top, but there's also some peer pressure coming from the side. And then there's all of these, I'm giving this talk, hoping to inspire some of you to think about documentation. And if it becomes like, yeah, it is an important thing and it's useful and it's fun, then people will hopefully start doing it better, more and more. Anything else?
What kind of tools do you use for automation? What kind of tools do you use for automation for documentation?
So there are these spell checkers available, or linters. Linters for code are available. Similarly, there are linters which check your grammar. So you can use that. Or then there are API documentation creators. Or so if you're thinking about anything like ChatGPT, does not really work because it gives you the answers. The English is very good, but it is so prose-like, it is so huge, and it is so boring to read. We get this written interview answers. So there is this written interview concept where you're supposed to answer questions written down. And we get all of these answers. Many of them are, and we know, you just read it and you know that it's ChatGPT who's answering and it's not a person. So if you really want people to use your documentation, you want it to be fun and you want it to be crisp and small and useful and not all of those big words and big statements. They're really good. I mean, you could use ChatGPT for listing out what you want to do or all the things that I want. But to get this nice, deep quality documentation, it's not ChatGPT's job, at least currently. But all of these other simpler tools, they are available for automation and we use them. Yes?
Any further questions? Otherwise, we will pass on to the next.
Thank you. Yeah.
Thank you very much.
So my question is this, like you need to be a career domain expert to be a content writer, but how exactly do you know that you're ready to be a technical writer?
Oh, that's a difficult question. Because I had no clue that I was. It was my whole interview process which suddenly turned into, oh, you'll be good for technical writer. It was this Daniel who saw that spark in me, and then I suddenly realized, oh, that makes sense. So, so if you have some interest in writing, some basic interest, and if you really like to, it's just not, I mean, you want things to be nice. And you mainly want things to be nice for the reader. You always think from the reader's perspective. So if you want it to be, oh wow, I like reading this stuff, and it should be good looking and it should be correct. Obviously, it has to be correct. You can't have mistakes. If you have that sort of an attitude, you can learn the domain, and you want to help them. You want to create something beautiful. It's a little difficult for me to explain, and it's not very obvious. But when we keep talking to them, you realize, oh yeah, this person can be a good technical writer. But yeah, I'm sorry, I don't have a better answer.
Any other questions? So seems not. And if you are now like a lot, would you also like to write documentation? I don't know whether there's perhaps also a canonical position that Slimpe knows. Well, yes, canonical is hiring also in this area. But also, if you look more like something more voluntary, we at Open Printing are also creating a documentation squad. And if you want to participate, you are also very highly welcome.
Thank you.
Your manager. Yes, you are his team. Yes, one sees you have given them in continuous workshop in the live division. And at least the first one. And one other thing, you do make in the time that I'm giving my talk a slide with QR code for the hiring. Yes. So that we in the panel about working economically, we can keep this project. Yes.
Till I guess you can start your talk.
Yes. Yes, now I will give a talk about Snap packaging and Ubuntu Core Desktop. The all Snap Linux distribution is a desktop version. And now I'm simply waiting for my slides being put up to the projector. And then I will begin with the talk.
Done.
Could you switch over to my slides?
Yeah, I switched it.
Yes. My slides are now there. Now, desktop Linux as easy as a smartphone, just in a snap. Next. So, what the hell are snaps and why should I use them? Next. Yes. That's one of or another of you develop an application, and so you already thought about how it should get distributed to the users, and this really can turn people away from Linux. Is you usually provide your application as source code, and then it's not easy. Only tech-savvy users can actually install from source. And for the others, you need the goodwill of distro maintainers to make a copy of distro packages. And if a distro version gets released, then the packages for it, there will be no newer versions added from the applications, and you would have to install a newer version from the distro to get a newer version from the application. And also, if you package your app for the distributions, you package it perhaps for 10 or more distributions, and you have tested for 10 or more distributions. This is a lot of work, and perhaps you will not have to do all this work, only to get your application around. So that's really a nightmare, isn't it? Next. So you have a smartphone. That's much easier. You go to the Apple App Store or to the Google Play Store, choose the application, and it works. And it is completely independent of what brand of smartphone you have. You get the same applications. And you can also remember that Canonical developed a smartphone operating system some years ago. And so they have a certain experience with that, and they have learned from it. And now what we have as a result, that's Snap. Next. So this is a method of operation independent packaging. And you package and test once, put your Snap into the Snap store, and then it works on any disk, on Ubuntu, on Debian, on SUSE, on Red Hat, on Windows, everywhere. And all libraries and other dependencies which your application needs, they are already included in the Snap. And so you have a user experience as it is with smartphone apps. And the application is running in security shell, which is combined from Armor, SecComp, and namespaces. And so it's isolated against the host system. And this we call sandbox packaging. And the communication to the outside goes through well-defined interfaces. And the Snap Store has control if an interface is a so-called dangerous interface, whether automatic connection to this interface is permitted or not. And this way, we can easily trust third-party packages and cannot only have packages which are approved and packaged by someone from Ubuntu. Or any other distribution, SUSE or Red Hat or something like that. So we are not dependent anymore on the distro maintainers, and so applications can be independently published and work on any distribution. You don't need always the newest distribution to get the newest applications. Next. So, and don't fear the demons. We snap them too. You know that there are perhaps other systems for sandbox packaging used in several already published immutable desktop distros. And these systems allow only packaging desktop applications, but not system applications, system components, daemons, like cuts, for example. And in Snap, we can snap everything, kernels, daemons, boot sequences, and everything what makes up an operating system, so we can really get an all Snap operating system. So we do not need to wrestle with different packaging formats, like a combination of one packaging system with another, like OCI containers and so on. So packaging this way moves from the distros to upstream. We have 10 or more distros, each are packaging the application XXX and inventing the wheel of packaging 10 times. So let upstream XXX.org snap it, and all the distros take the snap. So they save the work time for packaging by themselves. So the distro can concentrate on their distro core, or they can contribute to the upstream code. There can, for example, someone hired by the distro companies could code the new printing dialog for KDE, for example. And so when a distro version is released, the application updates continue from upstream, and so there's no problem that you don't have the newest distro. So, and the other thing are so-called immutable distros, where you have an immutable distro core. There's no write access to the core file system, so you cannot add classical packages to it. Only if you have very special tricks, we will hear at the end of today from Runa Saraswat about such a distro. Usually you have to use sandbox packages in an immutable distro, and therefore we use snaps for all snap distro. So we have an immutable distro core, and the snaps as these sandbox file systems are kind of immutable apps or immutable system components, and this is the way how we will have the future of Linux. So next. So now we get more to the details. Snap packages next. So we have compressed and GPG side with only squash FS image, where the application and all its libraries and dependencies is inside. And it includes also metadata in a YAML file. So for the snapd, for the system, to know how to install it, which interfaces to auto connect and so on. Then snaps, also each snap is installed with a writable file system area, also inside its capsule, so the snap can access. But every data which is user and runtime dependent will be written in this writable area. And on an update, it will be conserved to the next version. So, and snaps can be there in 4 types: in an application, an operating system core, a gadget. This is some kind of boot sequence, partition scheme, and so on. How to start the system before the kernel is loaded, and naturally the kernel. And later we will see that there's also a fifth type of a desktop environment when we go to Ubuntu Core Desktop. And so we have transactional atomic updates and rollback. Atomic updates means the thingy, our squash FS file system is replaced as a whole and not files spread into another file system. And we have rollback. The old version is always conserved. And if there's some problem, one can easily roll back. And if it's the kernel and panics, the rollback is even performed automatically, so that we do not get locked out. And we can handle binary diffs so that the updates from the snap store are much faster and less bandwidth consuming. And this is available on multiple distros and supported by default on Ubuntu since Ubuntu 14.04 next. So we have high security. Once the file system of the application is read-only, it's GPG signed. And we have a confinement, which I mentioned, by Paramore, which are file system access rules, SecCom, which are restrictions on system calls, and namespaces, which are separate resource spaces for process IDs, users, network, and so on. And we have snapd, which is the central component which controls the installing and updating of snaps. And we have snap confine, which wraps around all executables of the snap to ensure the restrictions, the allowed writable directories, and so on. Details you can also see on the internet when you take a photo of this slide, or when you download the slides, or simply from our website of the event. Next. So with this, the snaps are root safe because they are in the capsule, and so even if they are running as root, they cannot do anything nasty with the main system or with other snaps. So we can easily run all daemons as root. And we also do not need specific system users because we are in this capsule. And this makes things easier. And especially on this applies to daemon snaps, but probably also to the core snap and kernels and so on. They run also as root. And so interfaces, there we have a slot, so a snap, mainly the core snap, but also any snap can be this. This provides any possibility to connect, and any snap can with a plug connect to such a slot. And so one has an interface connection so that snaps can exchange information from one capsule into the other. And we have the rollback on error. We can have even an automatic rollback in case of a kernel panic or if the gadget snap already fails so that we do not lock out ourselves. So when there's an error, you simply perceive that the boot takes a bit longer, but it will boot. So next. So interfaces, we have safe and dangerous interfaces. Everything is completely encapsulated, and so we need the well-defined interfaces, like for example network, hubs, divas, and so. And we make the plug slot connection, and there are two types of interfaces. We have safe interfaces. These interfaces, when you connect them, usually the application snap cannot do anything nasty to the system. For example, the cut snap, which allows only listing the available printers and printing on them, but not creating or deleting new cuts, views, or seeing the job of other users. So this cut snap is safe, and so it will be automatically connected. Then there are dangerous interfaces. Example, the cuts control snap. This allows full access to the system's cuts daemon, including creating and deleting views and seeing all the jobs. So this is dangerous. An application snap could abuse it, and so it is. So we do not auto-connect it. And if you want to have it auto-connected, we have to apply for this at the Snapstart team on the Snapcraft.io forum, and they check your snap whether it does not do anything nasty with the dangerous interface. And if not, and if two members of the team vote for it, then you get the auto connection permission, and then your snap auto connects right when it's simply installed from the Snapstart. Next. So updating snaps, I already told we have atomic updates. So the whole file system of the snap is replaced by the new one. The old one is not deleted. Only the one before the old one gets deleted. So the last one is always there. And the writable space is passed over to the new snap. And so we get the new snap. And when you have any problem with the new snap, you can say, I roll back to the old one, and as the old one is still there, it simply works. And you can get to the old one which worked for you. Next. So now we come to the original operating system, why we have Snap. And this is the first whole Snap operating system which already exists. It's the Ubuntu core all Snap operating system. And next. And here we have, it was originally created for IoT and later also was used for server tasks. It does not have a desktop. So it's only command line. And so we have the following components. It's really all Snap, including its core parts. We have the gadget Snap. This is what is the very first which gets loaded and executed when booting, because this boots the kernel and prepares the kernel boot. For example, the mounting and assigning of partitions and so on. And also specific operation needed for your single board computer, for your microcontroller or whatever on which we are running. And it loads the kernel, which is also in a snap, so the kernel is separately updatable, also the created snap, and then the core snap gets loaded, which is the basic file system of the operating system, but it's a rather small operating system. It's much smaller than a standard installation of Ubuntu server. And so, yes, and so we have. And then we have the applications, and they are all in their separated sandboxes and can be separately updated and rolled back, and nothing happens to the core of the operating system. We have an immutable operating system. Many years back already, no one talked about immutable operating systems. Probably it was not so visible in former times because it was not a desktop operating system. So next. So on classic systems, yes. Now let's go to the core snap. On classic systems, we have a unified execution environment for all application snaps. And on all snap systems, we have a core snap, and this is actually the root file system. And there's just enough operating system to run the snap management daemon, system and a minimal set of system services, so it's not a full-fledged thing when you install a standard Ubuntu server. So and it provides the system level snap interfaces to this core system, like access to hardware, to the networking, to the control of the operating system, modules, devices, and so on. And it comes in with a built-in configuration interface to control certain aspects of the system via the snap get and set commands, so that you have some control by the command line on the system. Next. So we have the kernel snap. The kernel snap is a kernel in a snap. So it is minimally patched for this task, especially got some extra up armor bits. There's also documentation about how original kernels got patched so that one can snap them. And it ships with a generic init RD to set up the writable area for the read-only core snap. So for the core snap, the kernel already has to set up the writable area for the core snap, which comes after it. So and it's easily buildable by a snapcraft plugin. You need only a snapcraft.yaml file as for an application snap to be able to snap the kernel. And we can use also any BSD kernel, the board-specific kernel for certain developer boards. And it can be rolled back in case of a kernel panic even automatically. And it needs some default configuration options, and this is also documented. So next. So then the gadget snap. It defines the partitioning of the system image. Yes, usually when you have an all-snap operating system, it is provided not as an installer image, as we have with normal distribution. We have the system image, which when you put it onto storage media and boot from the storage media, you are already in your operating system, you do not install it then. So, and the partitioning scheme for this image is in the gadget snap. It also contains the bootloader and its configuration. And it defines board-specific interfaces for the case that it's for some developer board. And it can also define additional default snaps so that some applications are already installed right in the beginning in the image and do not need to be installed after the first boot. So an example is, for example, a Kodi appliance image. Kodi is a special desktop environment for a TV set for you sitting on the sofa with a remote control so that you can operate it. And use and make any computer to a smart, turn it into a smart TV. And one can make a simple image containing of a gadget snap, a kernel snap, a core snap, a Kodi snap, has some extra snaps. And so with this you can set up, have something which sets up easily a smart TV. Next. So Ubuntu Core Desktop. Now we add the desktop into the game. Next. We have already many desktop. So the desktop, we have many immutable distributions done by Red Hat, done by SUSE, and so on. And they work completely differently as Ubuntu Core. And now we want to have an all-snap desktop distribution. And this is one where the applications are installed as snaps, not only the applications, but everything of the systems are snaps. As with Ubuntu Core, but we add the desktop to it. So this should be easy to maintain for end users, like a smartphone. So you easily take snaps from the snapshot or applications, and even add alternative desktops or kernels, for example, gaming kernels, or switching from the original GNOME desktop to KDE, and so on. And it works very easily. You cannot do anything wrong. You can roll back, so it's all safe and consumer friendly, which is really missing in the standard distribution based on Debian or RPM or things like that. And so we have the boot base. This is the core snap. This is Ubuntu Core 20 or 22 or something. We have additional bases. For example, each application needs its core snap, and if you install it in application snap to a classic system, a core snap is installed along with it because it needs its base libraries, which are the core snap. And if you have now only application which have the same core snap as the boot base, then there's no other core snap on the system. But if you have an application which was snapped against another core snap, then the additional core snaps, these additional bases get installed. So, and now in the boot process, you have the gadget snap and the kernel snap, and snapd controlling anything. Snapd you had already also in the simple Ubuntu Core, and snapd is also by itself a snap, so the same way updatable. So the supervisor for everything is the same way updatable than everything else. Then you have the base snap, and then comes the new thing, which is the Ubuntu Desktop Session Snap. This contains the desktop. In our case, for the Ubuntu Core Desktop we are working on, it contains GNOME as the desktop. And it contains the display system, which is Wayland. And this way, with this module, we can get a graphical desktop, which desktop application snaps can use. And everything here is independently updatable and exchangeable. Next. So we have principally Ubuntu Core, but it comes with a desktop session snap, and we also ship it with some common applications so that a user can directly start working with it like he can with a classic Ubuntu distribution. So we will ship our Ubuntu Core desktop with a browser, with some office solution like LibreOffice and things like that, and so people can start right away and use it. And to build such a distribution, we have a so-called model. It's an instruction file which contains everything to build it. It contains which snaps we use as the gadget snap, as the kernel snap, as the desktop snap, and also which application we ship right in the beginning. For example, that the browser's on it, the tab snap is on it, so that users do not complain that they cannot print, and so on. And with these models, everyone can create such a model. So once we have released the Ubuntu Core desktop, it will not take long time that we get flavors from it. Like someone snaps KDE, and then we get a Ubuntu Core desktop, and someone makes some nice streaming kernels and takes the already existing KDE desktop snap, and so in this way builds Ubuntu Studio Core desktop and so on. And so we will get our flavors again. Perhaps the flavor maintainers will pick up on that. And so, and everything is easily exchangeable. So if you find the KDE desktop session snap in the Snap Store, and you have the original Ubuntu Core desktop, which is GNOME-based, you can install the KDE and switch to the KDE desktop. And with this modularity for the end user, it's really difficult to break the system. So next. So yes, as I already told, our first desktop session snap will use the Wayland user session, and it will use the GNOME desktop. So GNOME is running under the usual snap confinement. So the GNOME applications cannot directly access it. They have to use interfaces too, as we are used to. And all of the expected desktop services are also confined snaps. Our snap team is currently working also that we can snap user daemons, because up to now we could only snap system daemons. And with this, we can also snap desktop services to complete the picture. Next. So let us look into the making of how we create snaps. So a little bit of preparation also for the workshop later today. So next. At first, we have the tool Snapcraft. So this tool is the actual tool with which we build a snap, with which we snap an application. Snap packaging, we call it snapping. We snap an application. And so Snapcraft builds the snaps and then puts everything which we need together to create the immutable file system of the snap. And so we get a cohesive distributable package, this which we will put up into the Snap Store. It can reuse Debian packages, as the core Snap is a Debian distribution. And in our Snap build environment, only there, we can add Debian packages to it. We cannot do so in Ubuntu Core Desktop or Ubuntu Core, only in the Snap build environment. So we can get an environment in which we build the Snap, and can easily do it without needing to rebuild each library from source. And the Debian packages, as the core snaps are always based on an LTS of Ubuntu, which appears every 2 years, are always the packages of the LTS version. So we have to rebuild from source if we need a newer version of a library. So, and it's extensible, it has a theme of plugins and extensions so that we can easily build with different build environments like Make, AutoTools, QMake, CMake, and different programming languages like Python, Java, Go, C, and so on. Next. All the instructions to build a snap are in a single snapgraph.yaml file, which really describes everything. So it defines the applications which the snap should contain and which should be started by the user or by the system. And the build process, the build dependencies, the runtime dependencies, and also the interfaces. Then everything is fully supported and integrated in Launchpad. Launchpad, you know, is a classic distribution build management tool of Ubuntu. And Launchpad is also behind the Snap Store to build the snaps on a build server in a defined way. And also to build it in for the other architectures which the Snap developer does not have. For example, I'm developing the cut snap only on my laptop, which is AMD 64, and then the Snap Store Launchpad system is automatically building them for ARM HF and ARM 64. And so we have also the beta build service, the build snapcraft.io. We have detailed documentation and tutorials on snapcraft.io, also nicely ordered in the diataxis way. And we have also the snapping workshop, which will happen later today. So next. So we have Ubuntu Image for assembling an all-snap operating system, the magic tool for which takes the model and makes out of the model instructions an image. We also define the gadget with a gadget.yaml file to create a partitioning, and we can build full disk images, for example, an SD card which you plug into your Raspberry Pi, and when you boot, then you boot directly into your operating system without need of installing. There will be on Ubuntu Core Desktop, there will be some quick configuration dialog where you create your user on the first boot, but nothing more. Then you are inside. It's more or less like if you get a new smartphone and set it up. It's perhaps even quicker to do the setup. The setup is simpler, and so you get very quickly to your system, and you do not have the old way of installing and so on, which you knew before from having a computer as a consumer. And the Ubuntu image is naturally available as a snap in the Snap Store, so easy to get, and we have also documentation as usual. So next, yes, and if you want to know more, here are some ways. Next, we have the snaps. We have snapcraft.io where you find everything about Snap, especially also the Snap Store. And if you have questions, we have the Snap forum where Snap developers, but also other people from the community, people from Canonical's desktop team, where I'm also a member of, are there and answer your questions. And also from the other teams, naturally, foundations, kernel, server, depending.
If there is a question.
Yes, a question.
We get to learn how to snap, create our own snap.
Yes. We will have a workshop, so you can come to the workshop and then you learn snapping live here. So, and on snap.io you find also all the documentation. Next. And so if you want to learn a little bit about immutable operating system distributions, there's a nice blog done by the product manager of desktop of Canonical, Oliver Smith, under this address. And we have an introduction into Ubuntu Core Desktop by its leader, Ken Van Dyne, who is leading, coordinating the project, and where he has explained a little bit about Core Desktop. I also copied a little bit of his blog in this talk, and then the GitHub of Ubuntu Core Desktop, so that you can see out of which files it is made up, and how and you can even try it out with this. And here, last thing, Ubuntu Core Desktop installation, how to, if it's not so easy with the original, so you find it there. Next, I think we are at the end now. Yes, and here are also some more links, and even some videos on YouTube. So that's it. So everyone is now excited about Snap. Everyone wants to come to my workshop now later today. And also, if you now are thinking about immutable distributions and what we all have, several with Flatpak, then the new one with Snap, the Ubuntu Core Desktop, and then there's a very, very special one which is BlendOS by Una Saraswat, which we will see at the end of the day. So any further questions? No? Yes.
Like the Ubuntu Core Desktop, does it still come with the APT support that usually comes with Ubuntu normal desktop, normal distribution?
The Ubuntu's Core Desktop and the normal Ubuntu system, they will be both continue to be developed. We will not stop the Ubuntu Core Desktop. We will not stop the Ubuntu Classic installation. So you can choose whether you want to use Classic Ubuntu or whether you want to install an Ubuntu Core Desktop. So the Debian-based Ubuntu will live on. Any other questions? Let me see what's more. Can I see this in here, whether someone's going to get in also? No.
No, I don't think there are any
Is
questions.
are there external questions?
No.
Yes.
There is a question.
Yes.
So we also have flat packs. So how does it compare with snaps, the flat packs? Are they similar, or snaps is better, or they have different use cases?
The difference of snaps and flat packs is that flat packs, they are only working for desktop applications. The flat packs interfaces, called portals, are typical desktop connections. You have the flat pack, which is an immutable file system, also with its writable space. But for example, if you have LibreOffice in a Flatpak, to connect to the home directory of the user, what it does, it shouts into, when you want to open a file, it shouts into the dbus. I want to open a file. The desktop, the GNOME or KDE running, receives this shout and opens by itself, the desktop, not the application, the open file dialog, and opens the file and sends this file or handle to it back into the capsule of LibreOffice, so that LibreOffice receives the file, or at least the data in the file, so that the user can edit it. For save, the same thing happens, but with the save as dialog, or without dialog if it's just save, and the same also happens for print. So that the desktop's print dialog appears, And so what you see when you are running a GNOME application in KDE, and you have the Flatpak of the GNOME application, you will see that you get the KDE dialogs for open, save as, quit, and so on. And this is the way how Flatpaks communicate. This only works with desktop applications. With a demo, you cannot do that, or a system component. And even more, don't think about how to Flatpak the kernel without creating a new virtual machine. I mean, replacing the system's kernel. And so this is the big difference. There is some way to add system components to a Flatpak-based immutable distro. And this way is typically OCI containers with some appropriate interface like Podman or so on. And this way you could create a CUPS package which you could add to such a system. And this looks much more awkward. Ubuntu Core Desktop is really more streamlined. Did I answer your question?
Yeah.
Yes.
I think we need to start the next.
Yes. Now we will start the next session. The next session is a panel session about working at Canonical and applying for a job there. We have a Canonical gang here. Everyone who works at Canonical, please come to me. Yes, come to the front, take a seat in our panel. Yes. Yes. We will pass on this mic. Yes. Sit down here. So, could you represent show the slide? Yes, we will also put up a slide with a QR code so that if you are interested, you can easily connect to our job website. Yes, there will be some more slides we will show during the panel. And we will all tell about how it is working at Canonical, how we got into Canonical, and so on, so that you learn about how it all works, and that perhaps one or another of you could be interested. And as we are all work from home, it's no problem that you are living here in India and you would see difficulties, company from another country, but visa and so on. You don't need it. You work from home. You do not need any visa. You can work with us, and you even twice a year will travel to Europe and meet every one of us in person.
So, you can probably take over this question.
Yes.
So, I guess we just go around introducing ourselves. So, you guys already know about Till and Dimple by now. So, yeah, I'll start with my introduction. So, I'm Abhigyan. I work in the Web and Design team at Canonical. So, we are basically in charge of all the websites that you see. So, if you have ever gone to Ubuntu.com and downloaded the ISO, so you would have seen a lot of the websites that we have built along the way. So that being said, I work specifically at the commercial tribe there. So we are basically in charge of any commercial websites that are required. So how many of you here know about Ubuntu Pro? So it used to be Ubuntu Advantage, and you could get support for Ubuntu, for however many machines you like. And so, yeah, so we maintain the shop where you can buy subscriptions and manage those subscriptions. So I guess I'll hand it over to Arden to introduce himself.
So, hello everyone. I'm Aryan Porwal, currently working in the Android in a box, LX, and LXD, which is Linux Containers Organization, Linux Containers under Canonical. I'm a passionate software engineer who previously contributed to Google Center of Code in 2021 in the Zephyr Foundation. I also lead my college's open source society, so that's where my passion for open source started, and that's how I got introduced to open source. That's me.
Yeah, you all know me. My team is called Public Cloud. So we are actually the money-making part about Canonical. We make customized Ubuntu images for all the public clouds: Google, Amazon, AWS, Oracle, IBM, and you name it. They all use Ubuntu. I'm sure you have an idea about that. But those images are actually customized for each of those clouds to perform more efficiently and use all the cloud-related features. So that's the team that I work on, and I streamline the documentation for all of these squads for each of those clouds.
Yeah, so this slide is about Andbox, which is, so this is about, yeah, so we introduced this slide because we wanted to let everyone know that Canonical is not just about Ubuntu. So we work in different tribes. This is my tribe called Andbox, Android in a Box. So I'll introduce Andbox really quickly. Andbox is how you can stream Android in a cloud. You have Android containers running in cloud, and you can interact with them using web or CLI and stream it to your client devices. It runs on Linux containers, LXDs, which makes it ultra low latency, and it can be used for gaming, as you can see. So this is Bomb Squad running. If you have many more questions, you can ask us later.
Yes, and everyone probably knows me as the main organizer of this event and why this event takes place and so on. Yes, I'm the leader of Open Printing, and this is not a part of Canonical. This is a community project. Open Printing is even older than Canonical. It was born in 2001, while Canonical was born in 2004. And at Canonical, my main job is managing Open Printing. I'm in the desktop team, but I'm also responsible for the printing part of the Ubuntu distribution. And so I'm responsible for the Debian packages in the classic Ubuntu installation, which I'm doing in collaboration with Debian. Therefore, I go to Kochi after this event. And I'm also snapping cups, and integrating cups and printing in Ubuntu Core Desktop in the next few months. And also I'm due to the snapping cups and so on, I got a Snap enthusiast. For example, I'm giving talks about Snap as the previous ones and workshops. And I organized a Snap workshop series on the Ubuntu Summit 2022 and participated in the organization. So I'm also at Canonical doing some community work in collaboration with the community team. And that's it, what I'm doing at Canonical. And now let us perhaps ask everyone how he got aware of Canonical and decided for getting this job they have at Canonical.
So I made my first encounter with, I think Ubuntu was like when Windows 7 released, and basically it won't run on my old antiquated hardware. And so my friend was like, I have heard about this thing called Ubuntu, let's install it on your computer, and he deleted all my files. So yeah, that was a very solid introduction to Ubuntu, if I needed one. But yeah, so that is how I came to know about Ubuntu, and later on I learned that there was a whole company behind Ubuntu called Canonical, and when the opportunity presented itself, I applied just by looking at a banner on the website. So yeah, that's more or less how I came to know about Ubuntu. I mean,
So playing around with the Linux kernel was my master's thesis, trying to change it into incorporating a new protocol and so on. At that time, the kernel was extremely unstable. This is really old, this is like 2000 now. And we didn't have Ubuntu at that time, obviously. But then somehow Linux had always been part of my journey, and when I joined a small startup, it was obvious that we don't have the money to buy Windows, so all of our systems were automatically Linux based, and Ubuntu happened to be the best one, the most easiest one to play around with. So when I joined and I became, I did a lot of things, but I was also the system administrator, and I was playing around with Ubuntu for all our systems right from 2007 or so. And I've been a big fan and user since then. And when I decided to change my job, Canonical happened to be advertising jobs, and that's when I realized, Ubuntu is Canonical. I didn't know that before. Despite having been using Ubuntu for all of those years, I didn't know Canonical was behind Ubuntu. But luckily it all turned out fine.
So how I got to know about Ubuntu was, basically the same as I began. So I was frustrated with Windows Vista, I think, as far as I remember, and I also liked CLIs a lot. It was just intuitive to me and more fast than clicking around in GUIs. So that's how I got to know about Ubuntu. I started using Kali long before I came to know about Ubuntu. And how I got to know about Canonical was interesting. That happened in my college's open source society. A lot of people, I think I know about the Canonical from the Ubuntu installer. That's where it says powered by Canonical, and that's how I got to know there's a company behind it. And it was just natural to apply to an open source company after working and contributing to a lot of open source organizations. Canonical was one that supported open source aggressively.
Yes, and for me, I'm for a very long time at Ubuntu, since 2006. The Ubuntu Canonical was a 2-year-old baby, and for me it was in 2000, as perhaps one or another has heard in my open printing talk. I was in Paris at Mandi, and I did exactly the same work as I do currently as an employee in Mandi in the office in Paris. Don't speak French to me. And I'm in Mandi, since I joined 2000, they were healthy, and from 2001 on, they were a continuously sinking ship, hopping from one venture capital to the next one, and luckily surviving until 2015, where the ship actually sunk. And in 2006, when I organized my first open printing summit, I got invited once by the Free Standards Group, and second, on the Linux talk, I bumped into Mark Shuttleworth, and he invited me to Canonical, where I worked then in addition part-time. And it worked the way, this is the way how it was formerly, when Canonical was still small and not a big company as now, that people were hired more or less, that Mark has seen who are good people in free software community and could work together to build up a distro. And so when I had my open printing booth in 2006 in Wiesbaden on the Linux Tag, I was bumping into Mark Shuttleworth. There was an Ubuntu booth, and he told me how nice I was doing with the open printing, with the cups, with making printing so easy. And then he invited me to work at Canonical, and I lived still in Paris because I was at Microsoft. And the Ubuntu Developer Summit, shortly after, happened to run in Paris. And so they invited me to there, and there I was talking with my future line manager and with my future mentor. And so I learned everything about Canonical and had everything in my hands to make decisions which job I will take. And in the end, I ended up to run as a full-time on a free standards group, later Linux Foundation, and as a third time at Canonical. And later on, the splitting changed. The Linux Foundation was not so well anymore, so I could only run half-time there. Then Canonical has put me up on 2/3, and then later on Canonical has put me up on full-time. This was in 2012, and with this I had all the access to all the features and perks of Canonical working there. And so I was fully in Canonical, but my work was always the same, independently. The core part of my work is managing open printing, making printing just work. So now you know how I got into Canonical. But I'm an old veteran. I'm the oldest person in the desktop team of Canonical. Some people think it's Ken Van Dyne, but it's actually me. I'm 1970, he's 1971. And so I'm there for a long time, and so I don't know anything really about the way how one applies at Canonical and how one gets selected as at Canonical, as it is now a huge company which is advertising positions and hiring people. And as we are the pioneer in work from home since the beginning in 2004, everyone on the world can apply, so we get on each position a lot of applications, and so we have the way to get the best of the world for each position. And so we have unfortunately, a long way through the selection system to get hired. And I want to know the experience of everyone with that.
Yeah, so I think we should start with them because my experience was a bit different too. So we should start with
Okay. So applying at Canonical, it started with the career page, of course. After applying, my resume got shortlisted. Then the written interviews and all that happened. Canonical has a long process, that's for sure, but it's very fun. It's not something you'll get bored of and just slack off. It's something that you'll get involved in. You'll enjoy it. You'll learn a lot from the team as well because you'll meet the team in your interviews. Yeah, the one big part of it is you can ask questions to the interviewers. You can learn from them how their days, how their typical day looks like, and the culture fit is one thing that is important as well. That you understand what kind of culture Canonical has. That seemed very interesting to me. Most of these rounds are getting to know rounds, then technical rounds. How was your process like? Because you were
applied for a different role, right?
Yeah, so when I decided to change my job, I had no clue what job I should be applying for. And my friends basically said probably engineering manager is what suits you the best. So I applied for a fast track engineering manager role at Canonical. And well, I got an email from Mark, who's the CEO. He happened to be my hiring lead. And through the whole process, he would take things forward. So we have this concept of a hiring lead. So they know exactly what the business needs. And they know what they're looking for, not just for that specific role, but for all the different roles. Because all the hiring leads from different teams, they have meetings every Friday to discuss the candidates and to discuss what they want. And they can do things like, oh, I have this candidate and probably it's not a good fit here, but he or she is a good fit here, and so on. So my process when I applied for an engineering manager's role, I went through a long process and I had 10 different interviews, personal interviews, face to face. And this is apart from a big written interview at the beginning, and then there are 2 GIA tests, this personality kind of a test and an aptitude kind of a test. Yeah, so for engineering manager, those were the tests and those were the 10 different. So I talked to people right from a desktop engineer to directors of various domains, and finally the CTO and the CEO. So it was during my talk with the director of documentation, I just happened to mention that, oh, this seems like so much fun that you get to learn all of these new technologies. And during the process, I was going through what Canonical does. And it is definitely not just Ubuntu. Ubuntu is just the main core, and there are so many things around it. You wouldn't believe the amount of different things that Canonical does. I actually made up this whole picture, a map of all the things, all the software, the hardware, the different verticals, and all the different things that Canonical does. Because as an engineering manager's role, I was supposed to choose where you would be interested in joining. So I needed to figure out what is all of this and then maybe make a choice based on that. So it's like from every small thing, maybe a chip on a phone, or not phone is still a refrigerator, right up to all the cloud servers, anything that's big, anything that's small, everywhere you will find Ubuntu. And I could see that, and I was extremely excited about this whole idea of so much technology. And I was telling Daniel that, oh, this seems like so much fun, you get to learn so much. And if it is just documentation, or you just write it out, and all the fun is in the learning, and then side by side, I could also just make some money while writing stuff out. So he probably got this idea that, yeah, I'm better off doing this. And he told Mark in his report that she's probably better here. So when I reached Mark's interview, Mark was like, this is the feedback that I got. Would you like to apply for a different role? You'll probably fit in there better. And I was like, fine. And when then they said, okay, so whenever that role opens up, we'll get in touch with you. And when a few months down the line, the technical author role opened up, and Daniel actually got in touch with me and said, it's open now, apply again. And I applied again. I gave the written test again. The initial few things of getting to know type of interviews were skipped. But then my peer interviews happened with other technical authors, and then there was one test which was specifically testing about your writing skills. Like the engineering interviews have their own technical tests. So for documentation, there's a separate technical test. So it's a take-home test. I did that, and then you talk with the specific team that you would probably be working with. So I talked to the team, but then the time zones didn't match. So then there was another team that I talked to. I was happy to work different time zones anyway. We work random hours. I was happy to do that. But then they decided, no, this is a much bigger team and it's more flexible and this is nice and you fit in better here. And there are people from everywhere in the world in this team. And so on and so forth. So we finally chose another team. And then after all of that, I had to have another interview with Mark. So he takes the final call. And this time he remembered me, and it was a quick, short 15 minutes, so 20 minutes thing, and that was it. But it was this one process that I described took almost a year. So you need to have patience. I'm sure all the interviews don't go that long, but it is quite possible that it takes a few months, maybe 3 months or so. But since I went through totally different roles, and with a gap in between, the whole thing took 1 year. A lot of patience, but it's worth it because afterwards I realized, right, now when I go, there's this process called 360 where you review yourself and your boss asks you how you feel, and is it right, and so on and so forth, what you're doing. And now when I think back, I realize that whole interview process was actually good, and they actually found out that I can do a better computer, which I didn't know myself. And I'm actually happy doing all of what I'm doing now. And I wouldn't have figured that out just trying to apply to random jobs. So I'm quite happy about that. So that's my journey.
So yeah, the reason I am going last is because I had applied for a generic graduate role at Canonical, and so I went through, I think, 11 rounds of interviews. Okay, but you might be thinking it's very tedious. No, it wasn't, because at Canonical we let you schedule your interviews. So basically, you give your time preference, we have the people who are in the round of hiring, they have their time preferences, and then we select, okay, these two have this time in common, so you get a time which you are comfortable with. So we don't force you to stay up early, wake up early, or stay up late to, just conduct your interviews. I'll tell a bit about the process. So yeah, written interviews are the first step. Right, when you apply, and then since I was applying for a generic role, it was a big written interview, very different. And so once that was done, I went through a bit of just a culture fit interviews just to see whether I am good enough or not. And once those were done, I had to actually go through interviews with heads of 3 different teams. Because they were like, okay, you are good enough to be hired, but where can we put you? So I of course gave an interview with my current engineering director, Anthony, and I also had like 2 more interviews. One I remember with Evo, because I'm in the commercial squad and he's actually in the commercial team, which actually manages a lot of the backend. So I have to sometimes interact with him. And then there was, I forgot the third person, but I had to interview with 3 different teams and then give my preference that where I want to join. And once I selected, my preferences, they looked at the requirements and they figured out, so web and design is like somewhere we think you'll fit well and we have an opening at your level. And then in web and design, I had again 2 more interviews, I think. Where I was finally allotted a try, basically. So yeah, it is a bit a different process now. I think Aryan's is the closest one. So do you guys have any questions about the interview process? So if you have questions, just come forward, I guess. Or do we have a mic?
Yeah.
Okay, we have a separate mic. Yes.
So on the career stage, when we apply, so our resumes get shortlisted, right? So we get some sort of notification from Canonical, or like what happens after that?
So I think the written interview is after the resume shortlisting, right? So you'll get a mail asking you to have a written interview. So it's basically like a set of questions. If you apply, you'll get to know what the questions are.
How many people have visited the careers page here? You have. So you must have you applied though? Okay. Also, one thing about written interviews is that it is long. but it gives you a playing field, a level playing field, so that it doesn't introduce bias in the process. You can express yourself, express how your journey has been since your high school. You want to know who you are, what your story is, and that's one of the best. I think one of the best practices. I think it's one of the best process to know the candidate well. Yeah. Anything else about the process that you liked? Yeah, if you've not visited the Canonical Careers page, you can scan this page, canonical.com/careers, if you just want to type it.
Just one more question. So, like, is there any sort of hiring manager that we can get in touch with so that we can talk for like our colleges, career and placement center, that they can talk and like come here and like have some interviews?
So one thing about Canonical is we do not go anywhere to any universities to do placements because then you're restricting yourself to a particular geographic area, right? And when you're hiring remotely in like all 5 continents, habited continents, yeah, you don't want to bring in location bias or any biases as such. That being said, we are hiring throughout the year. Unlike other big companies, we do not have a certain time when we are hiring. Like in other companies, you have this placement season when companies have open roles for graduates and stuff. So we don't have something like that. We are on a need basis. So if a job needs to be done and we need people to be hired for it, then we hire.
Yes, one thing is important. Canonical is completely remote. Everywhere on the world you can apply. You have the same rights and the same chances everywhere where the internet can reach you. So if you want to work at Canonical, Canonical is always on the screen near you. And now I want to tell a little bit how we are working. We are all working from home, so we don't have to commute. We get up, have breakfast, get in our office, no traffic jams, no CO2 created by your car, not standing for hours in a full metro, and you right away start working. You do not need to dress up for your work, and so from this side it's very nice and easy. But then you can think I'm feeling completely alone when I'm in my home office and no one of my colleagues is there. So we have several levels of communication. We have a sophisticated chat system named MetaMost, where every team has their channels, so you can talk with each team. Some teams have set themselves up more sophisticated. For example, the desktop team has even 4 channels, and so you can easily communicate with any colleague. You can also directly chat one-to-one with each colleague in the MetaMost. And then the next level is you can use things like Google Meet to create video meetings, which we also often do. Many teams do this on a regular basis, for example, one weekly or every 2 weeks a week team meetings. One thing is we split the time in 2 weeks pulses, in which we have certain goals, and then the team, then there's every 2 weeks a team meeting about whether we have reached the goals and what we will do next and so on. And then there can be some sub-teams, for example, do stand-up meetings that every 2 days or so. In the beginning, not really the beginning, because everyone is in another time zone. There's a so-called stand-up meeting that they are talking about what they do in the next days and what are the current problems and challenges. And everyone can at any time do spontaneous video meetings also, and often to communicate between teams. And we are also even meeting in person, as 2 times a year we have the canonical sprints. Here. Yes. We will see some slides about the sprints. So we have many photos. Yes, now we are in the Czech Republic, where one of the last sprints, 2 of the last sprint sessions happen. Every half year we have a round of sprints. For most of the people, this is at one place. There's one is the roadmap and product sprint. It's only for the managers in Canonical. It's 1 week. And it was in the same city, the week right after is the engineering sprint, where all the people have to do with engineering meet. And this is nearly all Canonical. These are 700 people. And this means we need every half year a hotel, which is huge, which has 700 rooms free, for every one of us can sleep somewhere. And it needs around 40 or 50 meeting rooms, and it needs 1 plenary rooms where all the 700 fit in. And it works the way, and so I don't know exactly how the roadmap sprints work, because I'm not a manager role in Canonical. And I'm only on the engineering sprints 1 week every half year. And we have, you see there photos of our engineering sprint and roadmap sprint in November. Is it November 2022? 2022.
October is the product roadmap, and then in November you have.
Yes. And in parallel to the roadmap sprint, for every newcomer to Ubuntu, to Canonical, to get introduced with all the facilities of Canonical, we run an induction sprint. There the newcomers will get introduced with the sessions of the induction sprint. I think it's only 3 days, it's not the whole week. And then those who are in engineering, those newcomers who are in engineering, they stay over the weekend in the city, and they enter their first engineering sprint. And the engineering sprint, there we have 1 meeting room for each team. The desktop team has 1, the kernel team, the community team, and so on. Here, documentation and web have also 1, and so on. And there we are doing team internal work. We work together side by side for 1 week. We do team internal meetings in the morning, and in the afternoon we do team to team. We communicate between teams more or less. And we have also some plenary session in the morning, and in the end of the day we have lightning talks where people have something interesting to say and give in a quick 5-minute talk, tell about their work. And the plenary room is empty during the day. Anyone can also use the plenary room to create a session. For example, you can give a workshop. What I could do in the next engineering sprint, I could give a snack workshop there if I want. What all the time happens, Impel's boss, Daniele Procida, is giving diataxis documentation workshops in the plenary room during engineering sprints. Yes, so you see what there all happens. And one thing is we are all together. we have naturally a lot of hallway sessions. We are sitting together for breakfast and lunch, and we are going out for dinner. And so and after the dinner also for a beer, or we have the beer in the hotel bar. And so there's a lot of interaction between us. And so it's a lot of fun to be on an engineering sprint with all the people. And so engineering sprint, it's really a big event. And for our EA team, executive assistance team, it's it's a lot of work to find the hotel, to do all the infrastructure. There are something like 10 big boxes with equipment for AV, for network, for servers and everything, that this big meeting works. And so in Canonical, we got also a lot of experience with organizing conferences. And so we all are learning also from that. And coming to the next thing, these were the engineering sprints. Anyone wants to say something about the engineering sprints?
Yeah, so once you go to the sprint, you also, as Jill said, in the morning you work and then you're free to do anything you want in the evening. Evening. So roaming around the beautiful city of Prague, you can do that if you want to. And if you're in the induction sprint, you also get 2 days gap in the middle between the 2 sprints. So yeah, those are your free days for you to do. There's a treasure hunt during the induction sprint. So that time you'll actually get to explore whatever city you are in. So I think, so this time it's so Aryan is going for the induction sprint. So it's in Riga, Latvia. So yeah, you get to basically explore that city. By the time you're done with the treasure hunt, you know all the, public transportation in the city, and your legs will hurt. So yeah, carry running shoes for that purpose. We also have team-specific sprints where basically a particular team will meet up somewhere. So this was basically the web and design sprint that I attended last time in London. It was almost a year back. And there you can see the lovely people of web and design. So you talk and work and decide on what projects and what you're planning to do for the next few months. And yeah, again, weekends. So yeah, you go around the city, roam about, and hopefully also get some work done. And yeah, next to next week, both of us from web and design will be going to Berlin. These are not from the sprint, these are just generic Berlin pictures. And yeah, conferences. You want to talk about your conference?
Yes, and the next step is conferences. Canonical, as we are a totally remote company, we are very conference friendly to get more face-to-face with each other and also face-to-face with the community. So when you are working in Canonical, it is rather easy to get the permission to go to a conference, so that Canonical reimburses your expenses, and also that they have no problem that you are leaving Canonical for some days. And so, for example, I'm on very many conferences, but in addition, my work is leading open printing, and therefore they probably let me especially on many conferences. And also, one thing with conferences is I could even create a conference and I could get the full support from Canonical for it. Our conference website is the Indico from Canonical, the same Indico which was used for the Ubuntu summits. And our video system, StreamYard, is the same system as used on the Ubuntu summits. It's also used for the Ubuntu Indabas video shows, where a colleague of mine, who's unfortunately not at Canonical anymore, however elsewhere, has invited interesting people from the free software community and interviewed them, discussion with audience by typing, and so we got nice video shows. So we have creativity by different employees. For example, we in the desktop team have created the concept of the Indabas, and Heather has for a long time then hosted them. And also I have created a Snap workshop series in the Ubuntu Summit 2022. I got also full support of the community team and of all the colleagues who participated. So your creativity is very, very welcome. You do not only have to do what your boss is telling to you what to do, and so you get certain liberties, especially also that you can interact with the community if you want, because this is very important in open source and free software. It's everything community. Yes. Now you see a picture of the Linux Application Summit. The Linux Application Summit is an annual conference organized by KDE and GNOME, and in this conference there are people and also it's all about desktop applications, and it happened in 2022 in Rovereto in Italy, and in 2023 it happened in Brno, the city of the European Red Hat office, in the Czech Republic, 2 hours from the place where I live, from Vienna. You see here a dinner. Here's me on the very left, and you see Heather right at the side of me. We are very good friends because we are both very community oriented. We do a lot of community work, like organizing conferences. She does the video shows. She's participating in the organization of the Linux Application Summits. And then you see people from the community which were very close to us. For example, Lucy Levelin, she is the second on the right side. She works at Snapcrafter, so she's snapping applications, as I mentioned in my talk, where upstream is not snapping, and coordinating this snapping also in the community. She's not an employee of Canonical. In the very right, this is a manager of Thunderbird. It's Jason Evangelio, and so we were meeting here on the Linux Application Summit, had dinner together, and talked about everything. So this is networking. I didn't know Jason before, and I don't know when I I knew him, but I don't knew it. But we had and so we knew new people and what they are doing, and so we have contacts. For example, I can perhaps contact Jason to move Thunderbird to move that print dialog to the new architecture and so on. And another thing is, unluckily it happened that Heather has left Canonical, but probably because he got a good friend of Jason, she got quickly and immediately a job at Thunderbird. She's working now at Thunderbird. And so you can see how conferences can help you and can bring you forward. And so it's very important to attend conferences, to organize, to create and organize conferences, to bring the free software forward.
Yeah, hopefully you don't leave us.
Yes, yes. I hope also if you have made it into our nice, wonderful world of Canonical, that you stick with us. And I also want to say that the motivation of Heather to leave Canonical was not meeting Jason on this conference. The trigger for her leaving happened when I'm not going deep, very deep. Happened several weeks after the Linux Application Summit.
So basically the idea here is that you get to meet new people from the community and you get to meet the people who make the apps that you use daily, because when you open your laptop, you open Ubuntu, you use all this stuff and you don't really think about who's behind all this. And when you actually go to these conferences and you actually get to meet the people who are making these stuff, apart from further engineering skills that you can basically go up to anybody from the desktop team and be like, I love this or I don't like this, and share their opinions probably.
Before I start, do you have any questions? So one thing I wanted to point out is Canonical. One big part of Canonical, working at Canonical, is the travel. So if you like traveling, Canonical is probably the best place to be, because as I said, Abigail here has traveled. I think we'll travel 4 times a year, right?
Yes, yes. I'm a special example. That's also because I'm leading open printing. I have traveled in 2023 to this Linux Application Summit in Brno. This is number 1. Then I got to the engineering sprint a week later in Prague. This is number 2. Then Guadalajara, number 3. Then here, Opportunity Open Source is number 4. Then next week, DevConf is number 5. These are 2 on 1 trip. And then in October, I will be on the Mentor Summit in Sunnyvale from the Google Summer of Code. This is number 6. And then in November, I will be on the Ubuntu Summit in Riga. This is number 7. And the engineering sprint right after, also in Riga, it's number 8. So 8 conferences in 1 year and 6 trips.
Yeah, but
this is an extreme. You travel at least 2 times for 2 weeks. If you are a manager in engineering, you travel 2 times for 4 weeks away from home, and this is the minimum.
So 2 weeks, and if you join a team where they have special meetings at the end, then it becomes like 3 times a year. And most of them are in Europe because it's a central place. So you get to travel, and you can even extend your stay if you want to do some personal traveling on the side. So of course, Canonical does not pay for it. You have to pay extra from your side.
So one good thing.
And by the way, all the this is not working.
Okay. So one really interesting thing that I found is the cultural diversity. I mean, you've seen from the pictures, but it is really amazing. Your team members are right from Australia to Canada, everywhere, and there are so many different accents. And initially, it's a little difficult to understand all of them, but all the people are extremely nice. They are very enthusiastic, very helpful, and they're very passionate about their job. So all of my interviews, like I went through like 20 different people, each and every one of them was really nice. I mean, they were amazing characters, and that was like one of the main reasons I really wanted to join Canonical. That, and of course, there's traveling. So, and twice a year is pretty okay. You don't have to worry, even if you're not too much into traveling. Twice a year is a good number, and that's what most people do. So people and the people are really, really nice.
Yeah, a big part of our job is applying for visas.
Yes,
Unfortunately or fortunately, whatever.
My passport is a scrapbook now.
Yes, but the good thing, even these 8 events where being Canonical is reimbursing all the expenses to me, and they are really, really well, especially supporting this conference which I've created. It goes beyond my expenses. They gave me a lot of swag. They paid the extra baggage fees for all the swag, and they gave me the decoration for our venue and everything. So, and especially the Indico and the StreamYard, so that we could do this nice, great event here.
Okay, so you guys have heard all this. So what do you feel is the best part of working for Canonical? Like, what would make you apply? Apply कर रहे हो ना सब? Oh yeah. So another way Canonical is different from, I guess. So I had done an internship at Microsoft for 3 months, and so I feel the culture is a bit different. Even though I worked on, funnily enough, I worked at an open source project at Microsoft, which is strange. But
yes, you must know a little bit. The wall of Redmond has fallen some time ago, so they are also already well into open source, and probably it gets better. They have Leonard Pottering as an employee, so perhaps we see PID1 of Windows being systemd sooner or later, and hope that we will sooner or later see that CAPS also gets into Windows.
So how it's different is that, first of all, everything that you do, is on GitHub, so anybody can literally see your work, and I mean, you are building a really nice profile for yourself. And another thing, I think we forgot to mention what are the requirements to apply. Like, so you usually jobs have a job description, and they will have a list of requirements, the things that you must know before applying for the job. We have a few technologies that we usually use, but yeah, I think there's no technology that we don't use, or language.
Yeah, we use a lot of technologies. There's a high chance that whatever your tech stack you're working in we're using it already. We work on cutting edge technologies, and one big requirement is that you should be passionate about technology. You should like what you're doing, because we all love what we do. And so yeah, like how Dimple mentioned that she applied to a vague job description role, and then Canonical selected Canonical and Dimple decided on what she's gonna work at. So we tailored the job for you, and we select the best of the best.
Do you guys have any questions at this point?
Yeah, you're allowed to question during your whole interview process. You're allowed to ask as many questions as you want. You get to know us, and we get to know you. That's the whole idea there. And only if it's a really good fit between the two, you get actually selected. So, and it seems like things are being just repeated and all, or it's just all nice conversations. And it seems long, but all of that really makes sense in the whole process. So. It's a great environment if you really are interested in technology.
So
Yeah, so I had one doubt. How is Canonical different from other open source companies like Debian, Fedora, or Red Hat? Because they're also open source, so competition. So how does it fare?
First of all, I want to tell you that Debian is not a commercial company. Debian is a complete community effort. It's a community organization. There's no commercial company behind it. And the others, Red Hat and SUSE, they are more classical. They have their offices, and the typical, for the most time, the typical way to work there was to live in one of the cities where they have an office, and to go to the office, to do the commute, to have the permission to live there. But they are also partially doing work from home. So there are people who work from home for them, but as they are not these pure work from home as we are, they are not so sophisticated in doing work from home. They don't have these sprints and all things like that, and they don't let you so easily to go to any conference and pay everything, and therefore it is very different. Perhaps someone of you knows more about that?
No, I don't think any of us has worked at like another open source company.
Yes. I have worked at Mandriva, Microsoft in Paris for 6 years before I got to Canonical, and these were one of the classical office-based ones, and these are the ones how I imagine Red Hat and SUSE are. Microsoft does not exist anymore. They broke down in 2015, and so this is what I know. And we had no remote workers at Microsoft that time.
One thing that I get asked a lot is, does work from home get boring? So does anyone has any ideas like what do you do?
So I think this touches upon my work hours. So when you're working at a such a remotely distributed company, so you can also select your work hours. So like since I sleep late at night, wake up really late, so my work hours are adjusted, which works well with European times because I work late and I sleep late, so it fits in well with my lifestyle. And another thing is like I have a break in the middle, 2 hours, where for personal spacing out. Which you can do. You can literally say, okay, I work 5 hours now and 4 hours later, and you can do some scheduling stuff as long as your manager is okay with it. It should be fine.
Yes, and another thing, for example, I have already told to someone, to some people here that I have lived in 5 countries during all my life, and this is also a little bit due to Canonical. When I started at Canonical, I still lived in Paris, changing from Microsoft. Then I moved to Portugal for 1 year because my wife had a postdoc there. Then we moved to Berlin and stayed there for 7, 8 years. And then I moved to Brazil for 3 years, and then to Vienna. I'm living in Vienna now, and for Canonical it was no problem. I continued the job simply right away, non-stop, during all the time. And another thing, so while I'm living in Vienna, in the winter month, In the European winter, I was often going for 2 months to Brazil, to the parents of my wife. And so I had 2 summers a year, no problem with Canonical.
Yeah. I think one thing was that work from home, when you work from home, it does, some people feel that it gets boring, but you can travel a lot. You can, so I live in Bangalore, although we're from Bombay. So I specifically moved to Bangalore so that I can attend the tech meetups and meet new people every day. I work from a co-working space kind of thing. So I have colleagues from different companies, not just my own employer. And does anyone have any closing remarks?
Any more questions? Otherwise, we
Yeah, any more questions?
Yes, anyone, any more questions? No one? Now we have all convinced you that you want to work at Canonical? Or did we disattract you from Canonical? So that was this session about Canonical. I hope you have enjoyed it. And so we go on to the next session, which is, thank you very much. Thank you very much.
This is the next session.
Yes.
What is in this one? What is we have swapped this, we have swapped this. Yes. Yes. There is a smell of what is a technical office, a small like people want to give it, we want it. If people want to give a laptop, we want it, otherwise it's
Yes. Yes.
Okay. Thanks to the Canonical gang for the wonderful session. So if you can close this, Gagan, if you can close this one. Or we can do it from there.
Yeah, slide.
Were there any comments from outside?
No, put a break. Put a break.
Okay. So we'll have 15 more minutes before we go for the next break. And I mean, you have heard everyone from everyone how to apply for Canonical or other open source companies. But probably one thing which we have missed is how to start, how you start the journey, right? Before, say suppose once you are applying for Canonical or any other open source companies, what are the things that you should learn prior to that, or from where you should start? I guess many of you are hearing the term open source, maybe first year students or for the first time, you're hearing about free software, you're hearing about open source, you're hearing about this work from home culture. Now, post-COVID, everyone knows about what work from home is in India, but work from home is not a new concept. This has been there in US and Europe for quite a long period of time. People call it people have their garages as home office and they start working from there. As I was mentioning yesterday, that the best place to start is GSOC. And even you heard Suha yesterday talking about how you can apply for LF mentorship programs. So if you are willing to start your GSOC journey, maybe right now is a perfect time. Because you from now on you should start searching for which org you need to apply for or which particular subject makes you feel interested, which is it. Is it printing? Is it IoT? Is it something else? There are n number of things. First, you need to identify which one is of your interest. Because when you work on something which makes you feel interested, it's better. Right? So the first thing is identify those orgs or those projects, rather better to say projects, which makes you feel interested. Try learning their code, and typically what I try to say is like go through the README documents. Okay, that's like why technical documentation is very important, which people covered earlier today. And the next thing is like I mean, just try to install it, build it. If you find anything like put it in, create a pull request and change the documentation, that's fine. At least you need to start. So once you do that, the next thing is try contacting the community of that particular project, because every open source organization must be there in some community space, be it Discord, be it anywhere else. So identify that. So you typically get it in the website of that particular project. Start interacting with the people over there. Tell them if you find any bug, tell them that I figured out this bug, can you just put in a pull request, can you just check? So try to make yourself visible in the community. The more number of comments you put in there, people get to know you. Okay, this is a person who is working on our code or who is trying to modify something or do something else, right? So that's how you make your presence visible. Then when this particular organization is applying for any projects like Google Summer of Code or Outreach or whatever it is, mentorship program or whatever it is, then when you apply for a project, you are already known there. Right, so when there is a project and you apply for that project, the mentors might already be knowing you. They know like, okay, this is a guy who has contributed. I have seen him commenting in our chat sites or whatever it is. So you skip that evaluation part. Otherwise, like how competitive is it in GSOC? There are thousands and thousands of people applying for GSOC, if not 10 lakhs. So whenever application goes, it's hard for somebody to evaluate like, okay, whether should I select person A or person B. So every year for open printing, I'm getting 200 to 250 CVs, right? And it's very hard for me or peer to identify like who is the best candidate. And I should not deny this fact. Sometimes we miss in judging the right candidate because the person whom we select might not turn out to be the perfect or like they drop in between. So the best way is if you are willing to participate in any GSOC program or anything, you start contributing from now on so that once GSOC kicks in maybe January or February, people know you. And best place is like go to the website, start reading through the documentations, try building it. That is how you get to learn about it. There are typically there are few things whenever you are going for an open source company. Like typically there are few things that you learn that you should learn. That is Git. That's every company does it in Git nowadays. For open source, there's a version controlling. So these are the things you should learn. How the version controlling is done, what is a pull request, what is a merge, and all this stuff. And yes, so we heard nice things about Canonical, like how they are sponsoring the trips and how you get to travel twice or thrice or maybe 6 times a year. I mean, if you are lucky, like till. But even if you are not working in, I mean, that's a typical way how the open source companies does, right? So even if it is not Canonical, other companies they prefer working from home because the main concept of open source is like it's a global community. Open source is all about community. There is nothing in open source if there is no community. So even if you are not working in an open source company directly, but you have a different day job and you are contributing for open source. Like I have a different day job altogether. My company is not an open source company, but I have a different day job altogether. But I like open source. That's why whatever I do for open printing or Zephyr, I do not get paid for it. So that's like out of my interest. But I'm happy to say like it has been, I've been lucky enough to travel thrice a year or maybe 4 times a year in Europe and US, and all trips have been sponsored, so I didn't have to pay anything. Like if you apply for any conference and your talks get selected, or if you are a mentor, or you want to talk about something, you apply for it. And it's like if they select you, then they will sponsor for you. So I've traveled for Linux numbers in Lisbon. I've traveled to the Google headquarters for the GSOC Winter Summit maybe thrice or 4 times. I've traveled in Munich. I was supposed to travel for the Linux Foundation Member Summit, but unfortunately because of COVID, that got cancelled. So even if you are not directly working for open source companies, like you can still go there. And open source, another beauty of open source is like whether you are a student or you are not a student, anyone can contribute. Open source is for everybody. That's why in GSOC, the term student is no more there. They call it contributors. So earlier it was only for students. So now if you are not even a student, if you are passed out, if you are working somewhere, if you are new to open source, you can apply for it. So it's all about contributors. And before ending, another interesting thing that I want to talk about is I've been interacting with students from the last couple of years, maybe 2015-14 kind of space. So it's been like 7-8 years. I'm talking to students on open source and trying to build communities and all. The main problem that I see in India is we have many people contributing for the open source projects, but there is nobody who is doing the community stuff. Like all of you, what typically I've seen is you'll be applying for open source, you complete your projects, you put it up in your CV, that's something interesting to put, and you get selected for a job, and then you forget about it and you do not carry on with it. So that is something which is missing in India. Even like I was speaking to a couple of people in US or in Europe, like that is something they say, like we get very good talents from India. But what we do not see is people like who are managing the space, who are managing the communities, because it's all about communities. And luckily, like for the last few years, I'm seeing like few companies in India who are currently trying to promote or work in open source. They have started looking for community managers or people who can build communities. Like I'm not naming the company. This company is creating their own open source OS for mobiles, and I got a call from this company. They saw my profile in LinkedIn and they approached me like, "Hey, we see that you have done like, a lot of community job. You interact with the students, and like what we are trying to do is we are trying to create this open source OS for mobiles. So would you be interested for to help us build the community, because we want people from Southeast Asia and India. So we want you to talk to the students, make the OS popular, and basically create the community from scratch." But so that was interesting. And then again, there was another company last year who was trying to consult me to like how they can start their open source stuff. They wanted to convert one of their projects into an open source. They are trying to consult me like how and what are the benefits, or how people start contributing for it when it's open source. So this is quite interesting to see. Like in India, we are generating this concepts of community builders or community managers. So it's not about like whether what you are contributing. So you should carry on that. So either if you are contributing for any open source project, either you continue doing that, or you try to build community. So you can choose either of the two paths. So that is something quite interesting about open source. Any questions? No problem. Okay. Yeah, there is a question.
Sir, what's like the minimum skill required to get started on the course?
See, there is no minimum skill, so it depends on the. I mean, typically, what we say is you are, if you know any programming language, you know, like it's not hard to learn the other programming languages, right? So you should know the version controlling, and I mean, there is no place like there is no barrier. So just go for it. If you do not know anything, just try to go. I mean, as I said, read the documentation, read the README files. We'll start building it. Then you see like what the code is about. And any open source project will be having some bugs. Okay, so they put it up in Git. So and in few of the Git stuff, like there will be some tags like first timers or beginners. So try approaching those things first. So that is easy. Do not aim like Rome was not built in a day. So on the very first day, if you think like you can invent a rocket and get it to Chandrayaan 4, you cannot do it. End of the day, like you do it, you fall into some trouble and you avoid like continuing and you skip it from there. Don't do it. So it's okay. If you want to put in like some changes in the README stuff, go ahead and do it. Try to fix some easy bugs and then gradually improve or like increase your skill sets. What typically we do in open printing is many of you have received those things. When somebody approaches me like I am interested for open printing, so there is a typical set of easy things that I send to everyone, like build cups, change a line in the log, get it printed. So while doing it, you know how to download cups, how to build it, how to change something in the cups code, and how you get it in the logs. So while doing it, you learn the entire ecosystem of cups. The next thing is, if you are proficient in C, so you know how to change the code. And that is part 2. And the part 3 is like we have easy bugs. So it's either me or Till, we assign easy bugs to the students or the contributors. So once they complete that, we increase the complexity of the bug. And so we do not give a complex bug at the first shot. We give the easy, then the next one, then the next one. And once they are comfortable doing this entire thing, then we give them the actual projects to work on. So there is nothing like what all you should know. So you just go for it. Then in the journey you will learn. That's how like everyone learns. Any other question? Okay, fine. So thank you.
Yes, I also have something to say. How you could also get into the community to contribute. One thing is naturally, Avik has told about programming with Google Summer of Code. If you like to write, you can also get into the documentation part. This does not work by the Google Summer of Code, but every project needs naturally documentation. They have also a website where you have to write stuff. For example, blogging about the news in the project and things like that. So there's a lot of area. There's also UI design, and also an area if you are not a programmer. And so it's not only just programming. And another thing which I want to tell, as we are here in India, for Ubuntu, we want to have a local community in India. And so I want to know who all are interested in it. They could come to me. I have a QR code for you to scan so that you can sign up and that we can create meetings, virtual video meetings. There's also a mailing list, and so that it can be discussed how to do it, who does what, and so forth. So anyone who is interested, please come to me and I will give you the QR code.
With regards to the documentation, I forgot to mention one thing. Like apart from Google Summer of Code, there is another program from Google, like Google Season of Docs. So it's all about documentation. So if you are interested, so you get to write technical stuff about Google's Season of Docs. So even we had Piyush from this institute who had worked for Open Printing, Google Season of Docs, but unfortunately for the last few years, we from LF, we are not participating in Google Season of Docs. But that is very important because you might have created the best software in the world, like best open source software, but if you do not let people know how to use it, nobody will be able to use it, right? So that's how, like, every year there are millions of open source softwares that are born, but out of that, it's very few that make it to the final stage. It's one of the primary reasons is like the documentation. So that is why documentation is very important. You need to let people know how you want them to use your software. Okay, I think we are done, and we should break out.
Yes.
So post this, I guess it's your Snap workshop.
Yes.
So suppose this we will be having a split session. Snap workshop will be in some other room, and in this room we will be having a session on Zephyr from another speaker. So, and after that we will continue again in this room.
Which room is that? That's the last yesterday.
Okay, so the Snap workshop session will be upstairs, A3, 3A, and in this room we will continue with the Zephyr workshop.
How long is the break now? So anyone is interested in the local community of Ubuntu? Anyone of you wants to help the local community of Ubuntu?
Hi. Can you hear me? Hello, I have some sound. Hi. Can you hear me? Hello, I have some sound. Hi. Can you hear me? I can hear you. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello, I have some sound. Hi. Can you hear me? I hear myself with a delay. Hello? I have now. Hello? You can hear me? I cannot see you. But this is, that's great.
I hope someone is here. Yeah.
Good.
Can you hear us?
It seems like that, yes. I had a feedback loop with the audio running through around the planet and back to me because I didn't have any headset. But now with a headset, it's fine.
Okay, that's perfect. We will, once you start your talk, we will. So once you start your talk, we will put ourselves on mute.
Yeah.
Give us another 5 minutes for others to come in, so we just had a break.
No, this was not more times.
So is the sound good for you from my side?
Yes, it is. Can you try speaking?
Yes. Yes, I can hear you. Now it's better.
Oliver, can you hear us?
Yes. Very nice.
Okay, so we are removing you from the stage for a few minutes. So once we start, we will put you back on the stage.
Hello? Hello, can you hear me? So I'm ready here in Germany. Time zone is 3.5 hours behind India. Okay. You can hear me? Okay. I cannot see the presentation right now. Is that normal? Because during the test I could see it. I could also switch to the YouTube connection. Ah, okay. So you would like me to present it. Okay. Should I present it from StreamYard? Should I try that? Just a moment. Okay. Just a moment, because I expected this to be different, but no problem. And choose the slides. Okay. Present. From my computer. Okay, it should take a few seconds, but it should work very quickly. Okay, now I'm now uploading the PDF slides. Okay, they're uploaded. And I will now, okay, 40 minutes. Okay, I'm fine for that. So I will present this in a few seconds. Okay, fine. Can you see my first slide? Okay. So I do not get any audio feedback right now. Now I can hear you. Fine. Thank you. Good. Okay, so you can see my first slide. Great. Wonderful. Okay, so I say hello from Berlin, Germany. I'm Oliver Völkers from Berliner Sensortechnik. Now, Berliner Sensortechnik is obviously located in Berlin, Germany. The abbreviation of Berliner Sensortechnik is BEST, and we think that's a nice abbreviation. And what we are doing is we develop custom-specific sensor applications. So we invent sensors, and I use existing sensors and add some firmware to it, add some software to it to make them usable. My background is I'm a computer scientist from the Technical University of Berlin, and I have experience in sensor design and embedded software development. and also with pattern recognition and artificial intelligence. So I specialized in signal interpretation, pattern recognition for many years now. Okay, so the subject that we are talking now, or the project that I'm talking about, is a high-speed train wastewater monitoring and how we use open source software in that area. So the project that we have been doing is that you see a high-speed train there on the photo. The white and red striped train is an ICE train, which means Intercity Express in Germany. And these trains, like all trains, they have bathrooms, they have toilets, and they have restaurants. And this wastewater is collected in a tank, in a wastewater tank. And this wastewater tank is at the side of the train. It's accessible, and they need to be emptied. And they are emptied in special maintenance station. And you can see that on the photo there on the right side. You can see the pipe connection, which is connected to the train. And the little black box with a green light is the module that we have been building. And this little module runs the operating system Zephyr that we are talking about now. And this is a battery operated system. The connection is only via a mobile radio. So there's no wired connection and there is no energy supply. So we have to be very energy sufficient. On the right side, we see this module again, the best sensor wastewater monitor. And it's a hybrid sensor system with a pattern recognition. And inside, there's a microcontroller, an ARM RISC microcontroller, the Nordic Semiconductor NRF 9160, which is an integrated system in package with LTE. LTE is a long-term evolution mobile data connection. In fact, it's a variant called LTE-M to send data over the mobile phone network. This module that we see on the right side is a commercial product which is in use for over 2 years now, and it runs Zephyr RTOS, real-time operating system. And it was developed by Jonas Remmert, who you already know from the conference, I think, and Oliver Völkers, that's me. Now, the challenges of this project were quite, there were quite a lot of challenges. And you might have heard about the iron triangle of project management, which is quite old. In fact, it's decades old, or I think older than 40 years now. And the idea or the message is that you want to have a cheap product, cheap development, you want to have a good development, and you want to have it fast. But you cannot have all of these together. You can have 2 out of 3. So if you want to have a cheap and good product, then it takes very long to develop. If you want to have a good and fast product, then it's very expensive to develop. And if you want to have a fast and cheap product, well, then it's crappy, as you all know. So that's typically a contradiction which is very difficult to get out. And the subject of this talk today is how we can somehow escape this iron triangle with the help of open source software. So what can we do to have both a good product and a fast product and a cheap product, all this at the same time? How can we achieve that? Now, of course, the demands from the Deutsche Bahn, the railway operator, the Deutsche Bahn, these demands are quite high because you can see the train there on the right side with the wastewater pumps. So the T-formed pipes, they sort of, with a vacuum, they pump the wastewater out of the wastewater tanks from the trains during night hours mostly, because during the day the trains are running, so it's mostly during the night, but not only during the night. And of course, Deutsche Bahn wants to know whether these pumps are operating properly. So they don't accept false alarms. So if we would send an alert and tell them that something is wrong and there's nothing wrong, then they would be unhappy about that because it would cause cost. And also, if there's a problem with the pumping, if there's a blockage that we would oversee, that we would not notice, then there would also be a problem. So they want a very high recognition rate. They want a very reliable system. And they want a very robust system, obviously, because on the maintenance side, the work is running 24/7. So around the clock, people are working. But there's no IT administrator or something like that. So these units should work without any supervision. They should work automatically. And another requirement is the flexibility, which means that new train types might be introduced and the pumps can change. And we should not need to replace the units just in order to adapt to these. Now, how can open source solve some of these issues? Not all of them. The open source idea is that everybody can contribute. You can share your own work. You can get support from others. You have full transparency. There are frequent versions. And you have a high degree of modularity because there's so many people are working together. So in order to divide the responsibility, these modules, many modules have to fit together. So it's a very cooperative work. And there can be dynamic decisions because an open source project is typically very much alive because many people are very active in it. And reasons to use open source software is access to newest developments because it's updated permanently. There's better cooperation, and there are, as I mentioned, frequent versions and dynamic decisions. So it can be extremely productive, but there can also be difficulties with open source. And some criticism of open source software is that it can be chaotic, it can be uncontrollable, then there can be a lack of responsibility. And the biggest issue that some people have is that there's no confidentiality because it's absolutely open. So if you want to keep something secret, then you shouldn't use open source, obviously. Then you should use closed source. And there might be some reasons to do that, for example, with banking software or something else, where you don't want anybody else to have the key to what you are doing. But everything depends on the people involved. So if the people are enthusiastic about it, then you have an excellent project. If people have less experience or are less enthusiastic or less motivated, then progress will be slower because it depends very much on the motivation and the capability and the expertise of the involved people. But usually in an open source software project, everybody is engaged because otherwise there's no point to work in it. So nobody, there are no free riders or something like that usually. So there's nobody who is just trying to impress other people as there is in commercial projects, because there's no win in just trying to impress if you don't have anything to show. If you have no real result, then there's no point participating in an open source project. You can use the software, of course, but you will then not contribute. And if we return to the iron triangle and to the question how open source can contribute to that, well, it can be cheap because it's not commercial. It can be fast because many people cooperate. And the quality depends on the quality of the cooperation. It all depends on the people. So that's why we are talking here and why you can see that you can make a difference. So if you can make a better contribution, then the result will be better for everybody. Now, the question is about the operating system, because the subject today is not only open source, it's also which operating system to use. Now, on this diagram, you see from the left to the right the degree of complexity. So on the left side, the so-called bare metal. Bare metal means you have a microcontroller and you have essentially no operating system. You just run the code. So there's no scheduling and there are no drivers or anything. A good example of that is typically Arduino, although Arduino is today very capable, so you could have drivers and you could have a full operating system as well. But in its easiest and its simplest incarnation, then Arduino can be very, very simple. And a simple microcontroller, which was common 10, 20, 30 years ago, with just a few lines of C code, that is a so-called bare metal. And with adding some complexity with real-time operation and multitasking, maybe wireless, you need an embedded OS. And if you add some more complexity, you can have a full-site OS like a Linux or like Ubuntu. So obviously we are at an Ubuntu event here. Ubuntu is a variant of Linux, and it's very capable. Everybody knows that. So, and for example, myself, I use Ubuntu for development of the wastewater monitor. So that and Ubuntu, we use Ubuntu in order to develop Zephyr. And so it's very capable. But the question then is, why would one not use a full-sized OS? Because a full-sized OS is obviously more capable than an embedded OS. It can do more because you can install software, you can have more drivers, you can hot plug peripherals, so you can plug in a printer, you can unplug the printer, you can connect a mouse, so you can do all kinds of things with a full-sized operating system. However, a full-sized operating system also has some drawbacks. And the drawbacks of a full-sized operating system is, firstly, it uses more memory, it uses more processing power, so more CPU time because there's more overhead. But another disadvantage, which is which can be very significant, is energy efficiency. Because if you need more resources with a full-sized OS, you will use the batteries faster. And in our application with wastewater monitor, we have a battery-operated system. So we depend fully on an efficient system. If we have twice the energy that we use, then we have half the runtime. So it makes a difference between having, let's say, 1 month of battery time, runtime, or 2 months or 3 months. But we are really talking about several months of operation. So it's not hours or days. We are talking about months of operation for this small unit that is battery operated and which is online all the time. So you can imagine that it's quite an achievement. And you can see that the Zephyr operating system must be very capable in order to do that. So an embedded RTOS, an embedded real-time operating system like Zephyr, is capable enough in order to build something like this wastewater monitor with signal processing, sensor data interpretation, and with wireless connection, because all the measurements are sent wirelessly. And it can handle multitasking, and it can have wireless connection at the same time as it is doing measurements. So it can do that in parallel, which is not possible with a bare metal system. So a simple system would not be capable of doing that all at the same time. On the other hand, the advantage of Zephyr is that it does not have the complexity of a full-sized Linux or Ubuntu. Now, another commercial reason to use Zephyr, which is it's a really fundamental, practically we had no choice. We had to use Zephyr, and the reason was that the railway operator Deutsche Bahn, they requested from us that we would offer years of support. Now, how can we offer years of support if we don't know if the commercial supplier will not be around in a few years anymore? And how can we offer years of support if we are connected to a commercial operating system? And we made this experience in the past. In fact, when we worked for a remote control manufacturer in Singapore, we had a development system which relied on Windows, and in this case on Windows 7. And when we continued to develop, there was a transition to Windows 10. So we made the transition to Windows 10 as well. But then we had to make a change, and we had to return to an older version. And we could not return to the older version because the operating system simply refused to work with the older Windows. This kind of problem will not occur with open source, and it will not occur with Ubuntu, it will not occur with Zephyr. Because with Zephyr, you are free to use any version that you like, even an older version, so you can move forward and back as you like. And also because it's not commercial, you can have a great cooperation. You can have lots of developers cooperating with you, and you don't have to pay a monthly license fee as you need to do if you have a commercial license. Another advantage is it can not be taken away from you. So with a commercial system, if the company that produces it withdraws, goes away from the market, or they increase the prices, and it does happen, then you completely depend on it. They can, it's not ransomware, but it's a little bit like that. So you are forced to pay fees that you might not want to do. And in this case, our customer, the Deutsche Bahn, the railway operator, they demanded that we should be functional, that we should be operational even in years to come. And that is something that we can guarantee, because we can be sure that in 3 years of time, we will still be able to have access to our source code and to our development. Okay, so why do we use Zephyr real-time operating system for wastewater monitoring? The technical parameters are, of course, we need an embedded RTOS, an embedded real-time operating system. We need real-time operation, so we need the energy saving features, and we need multitasking of peripherals. So that is why we do not use bare metal, as I explained. Also, a full-sized Linux would use too much energy. So that's why we are exactly right with an embedded RTOS. And the economic reasons to choose Zephyr from other real-time operating systems, and so there are other commercial or half-commercial real-time operating systems in the embedded area. And the reason for us to pick Zephyr is that we have the long-term serviceability, and we have 100% control over the source code. And this also means increased safety. And safety, as you can imagine, for a railway operator is fundamental, because if you have an open source project, you can check yourself if there are any backdoors or if there are any issues. Everybody can make sure that there is no harmful code in it. And in fact, it's the only way to build a really safe system, because if it's closed source, you never know. There can always be something in it that you don't know, that you cannot control, and you simply have to trust the company that sells it to you. And the trust might be justified or not. So, concluding now is, in what way did we work with the wastewater monitor project? It was a bit special because it was a completely new application. So it didn't exist before. So we had to sort of invent it. We had to build the plane while we were flying it. And that's the case with many innovative projects. You do not know in advance exactly what you will have in the end. So there's no precise definition of the requirements available in advance. And this was the case because the railway operators, they just knew that they wanted some kind of monitoring of the pumps, and they wanted to make sure that it works. They wanted some visibility of the problems. They wanted to get an alarm when something goes wrong, but they did not specify the exact format of the messages. They did not know exactly. We didn't know the battery runtime. We did not expect that it would run for months. In fact, we thought in the beginning, we would be able to achieve maybe 3 weeks, but we then achieved at least 3 months, and we are on track to, our target is to have 1 year of battery operation. And just imagine that if you have a mobile phone, of course it's smaller, but still, if you have a wireless connection there, it's very rare to have a system with a wireless connection that is always on and which runs for months. It's really rare. And this is possible with Zephyr. It's possible because of the Nordic semiconductor NRF 9160, which is a very capable and modern microcontroller. And now returning to the agile work style that we used, when you have, we have clear requirements, but we still had a moving target, because when we worked out something, then the customer might say, okay, this LED signal is very nice, but the LEDs should be a little bit brighter. Or let's say the speed of the LEDs, of the running LEDs, is a bit confusing. Maybe they should move slower, something like that. You do not know that in advance, because you have to test it all the time, and you need to get feedback in order to get a good system, because we made prototypes and proof of concept, and then we adjusted everything permanently. So we had a moving target. But in order not to fail, we always kept a working system. And when we tested something, we just tested it, and either it was an improvement or not. And if it was not an improvement, then we returned to the previous version. And open source software and the work style of open source software very much supports that. As I said, you can move back to older versions of the operating system and so on. So we could experiment. We were not afraid to use the newest versions, because we knew that we could always return to older versions. And the progress that we had was from a proof of concept. So the first attempt, I was asked by the customer, can we do it? And I said, yes, I think so. So we built a proof of concept at first with a very limited contract, which was just about the proof of concept. And the proof of concept worked well. And then, the reason why we needed a proof of concept was that you might have heard, or you might wonder, why is wastewater monitoring so difficult? The reason why wastewater monitoring is difficult is that usually liquids can be detected with flow meters. And there are many flow meters on the market available, electronic flow meters that detect flow of water or flow of oil. There are lots of these, and they work very well. With wastewater, it's more difficult, because the wastewater can be foam, and from the, let's say, from the restaurant, from the dishwasher. It can be water, it can be toilet paper, it can be fixed stuff, and it can be bubbles, it can be air, it can be nothing. So it can be empty, the pipe can be empty. And all these different conditions must be recognized. So that was why we needed a proof of concept. Then we had a small run of prototypes. So after we built one, we built 5 in order to make sure that it doesn't work only on a single unit, but also on several rail wagons. And then we built a pre-series, which is now, we built about 50 completed modules, and we built around 100 PCBs in order to have some replacements. And these modules are now in use for almost 2 years now. So we have a lot of experience, and we, in parallel to these modules, we built an electronic system with MQTT. MQTT means that the data from the measurements are transmitted to intermediate connection, and from there they are transmitted to the customer. And it's a so-called edge system, which means that all processing is done locally. So we do not transmit the raw data. The raw data are all processed in the unit itself. And a fundamental decision was that, like almost every large project, we have a mixture of open and non-open source. So this is not all open source. That would not work. Why would it not work? Because there are some algorithms which are not, where the customer or other partners do not want to open them. For example, with LTE connections, if the protocol and even the passwords or something like that would be openly available, then interference would be possible from third parties. So, and also with Deutsche Bahn, they have some, not much, but they have a few connections or a little bit of information that is proprietary and which is confidential to them. So not everything is open source in this project. And in fact, if you see large software projects like operating system, like let's say the Apple iPhone, the iOS or Android for mobile phones, if you look at the legal statements, you can see that they have lots and lots of open source, but not everything is open source. There might be a video codec or something like that, which is proprietary. And they can work quite well together. So you do not need to have 100% open source for such a project. Okay, to summarize, what did we achieve? We had the task to develop a monitoring system that will detect and report failures automatically. On the right side, you see again the module that we developed with a little green light. The black box is our module, and the pipe on the left is part of the pump, and the right side is part of the rail. That's a high-speed ICE train, and that's from daily use, so they are in operation all the time. And 24/7, they turn on automatically. There are no user serviceable parts, so there is no on and off switch. There is no button to press, because if there is no button to press, then it's not possible to do something wrong. It turns on automatically, fully automatically, so it detects automatically when the pumping process begins, and it will turn off automatically when it detects that the deposit has ended. And over the time, we have tens of thousands of deposits that have been analyzed and that have been recognized. And the failures, if there were some, and of course there were some, they were reported immediately. And in this case, I didn't mention the NFC connection. So there's a near field communication. There's a little NFC tag at the side of the railway wagon. And this NFC tag will have the information of the wagon number, the train number, and also the tank number. And in order to report a problem, of course, because the railway is moving, you see the train is for maintenance in the station, but of course the timetables are tight and the train has to leave the maintenance station quite quickly. But if there's a problem, it will not be fixed immediately. So it will need to be registered. So we need a notice. And in our case, if there's a problem, there will not be the green light as we see on the photo, there will be a red light. And the operator will see that something has been wrong, that there's some kind of blockage. And they don't have to do anything because automatically the message will be sent, and it will be sent including the type of the problem and which train, at which time, at which place, and which tank, at which kind of problem. So the customer, they see immediately that there's a problem, and they can use that information in order to fix it. So they can order, they can prepare for a repair in this case. So they will reserve some time in the maintenance station. So this is of course very nice, and we are happy about the system that is running smooth. And Deutsche Bahn has declared that they will roll it out much further, so it will become a standard solution in Germany at the railway maintenance station. So it will be a much larger system. Right now we have 36, but there will be several hundreds of them working permanently. Okay, if you would like more information about this, this is the last slide. There's a page on the Zephyr project page with some links, and there are a few YouTube pages. where you can, for example, enter my name. In the middle, you have the presentation in Prague from the embedded open source summit, which was in June of this year, I think, so a few months ago. And on the right side, you see 2 YouTube videos where we were interviewed at the Embedded World Conference and Trade Show in Nuremberg in Germany. So the Embedded Open Source Summit was in Prague in Czech Republic, and the other 2 videos were recorded in Nuremberg in Germany, where we had a presentation. Jonas and I had a presentation, and after that we were interviewed, so you can get some information about there. And if you like, you can always contact me. You can send me an email. You will find it out on our webpage, and you can request more information if you want, because what we have found out, and that is something that I must admit that I learned from the open source community, is that exchanging information freely will give much more return than one can imagine. So you learn a lot, and you might have seen from my biography that I have patented. I have several patents in the area of membrane sensors. So you might be surprised, why should I talk at an open source conference? And the reason is that I have learned that was what was appropriate maybe a few decades ago is not appropriate anymore. So today it is a good idea to very openly share information, because everybody will have the advantage from that, and information will grow. If you share it, you will not lose anything by sharing. So it's a misunderstanding that I had in the past, that by keeping information exclusive, you would be better off. That is not the case. So, okay, so thank you. That is from my side. And I'm finished now. And if you like, we can take a few questions. I think we still have 5 or 10 minutes. I don't know exactly.
Any questions?
Guys, we are
No questions? Hello, Oliver, can you hear us?
Yes, I can hear you.
Okay, so guys, any questions from anyone? I don't think there are any questions, so I'll just check if there are any questions that have come online.
Okay. So,
no, there are no questions.
Okay, there might be, and if there are questions in a chat, there might also be a chat, but I think, I'm not sure about the YouTube.
No, I just checked YouTube, there are no questions.
Okay, great. Okay, so we are finished then, I think.
Thank you, Oliver, for the excellent talk. Thank you.
Thanks a lot for having me present to you. It was an honor for me to speak to you. And greetings from Germany. Goodbye.
Goodbye. Goodbye. है ना नेक्स्ट सेशन है ऊपर नीचे ऊपर वाला खत्म हो जाएगा वो लोग नीचे आ जाएंगे तब सही होगा अभी 3 मिनट बाकी है
So guys, next session is from Ubuntu Service on Client OS. So I'm just checking if he is ready. He's joining in a few minutes. Maybe we can do the sound test.
Right? The next session is really interesting session. Please pay attention to it, and it is like required that please have a laptop with laptop. If anybody is not having, they can bring the laptop.
Rudra, can you hear us? Not able to hear you.
speaker on? Oh, sorry, this is a free. Hello. Rudra, can you hear us? No, we cannot hear you.
No. Can you hear me now?
Yes, we can hear you now.
All right, sure. This is first lecture.
Rudra, just give us 5 minutes. There are some more people who wants to join in, so we'll just check with them. Just give
Yeah,
us
sure.
5 to 10 minutes.
Sure.
Guys,
Present Muslims.
Rudra, can you start speaking something?
Sure. I've made my presentation though.
You are audible. You are audible.
Yeah. I can't see my presentation.
If you have, if you have any slides, try to just present it and we'll put it on backstage.
Sure. I'll do that now. Hey everyone. I'm Jude, sir. I'm the release manager and developer of Ubuntu Unity and the project lead of CentOS, or the latter of which is an immutable and atomic Linux distribution with support for packages from 9 Linux distributions, as well as Android apps. And I'll be going into the nitty-gritty of such distributions, and we'll be discussing how CentOS implements immutability and atomic updates. Let's go back all the way to the basics. What is a Linux distribution? To some, it's an operating system that ships a proper init system, along the likes of systemd, runit, the original upstart, and quite a few others. You usually have a package manager, unless you're talking about LFS. You have deb or apt, you have RPM, you have RPMs and TNF or Zephyr. Then some distributions like Slackware, they build directly from source starballs. You have both systems like you have PKG builds on Arch or Gentoo's Portage. You have your C library, glibc, which you could also swap out for. You could swap out for for an example would be Muscle. Alpine Linux uses Muscle, for example. Though most programs aren't exactly compatible with it, since they're usually linked with glibc, so that's one thing. You usually have a bootloader, though that isn't the case in container distributions or container images for that matter. You have the core utils as well, which provide all of your standard utilities you would expect to see on a Unix-like system. You have all of your standard commands like ls, test, to all of them, and then you have a whole bunch of other components. You have systemd network. If you're using systemd, for example, you have resolved, you have nspawn, and all of them. You have X11 or Valent. You have your display manager. If you talk only about desktop Linux distributions. This, however, isn't exactly representative of all the distributions out there, including those that do not ship GNU utilities like Alpine Linux or its multiple derivatives like Postmarket OS for phones and Android. This just so happens to be a highly contentious topic, but I would argue they're just as much of Linux distributions as all the others you'd expect to see on a regular Linux system. Now coming to immutability, what exactly do I mean by it? After all, you could simply remount your root file system with the RO option to make your system read-only. This, however, does necessitate separate mounts or partitions for all of the system directories, home, etc. for all of them, and contrary to a popular belief, most users do not opt for separate home partitions. So that's another thing. So yeah, this is not exactly a viable solution, and an immutable system, an immutable Linux distribution to be precise, is one that allows you to get your work done without ever having to tamper with your base system, or letting you for that matter. As for atomicity, which you're probably already familiar with if you studied CS, the acid properties, is the property of a transaction or system where a set of operations take place in one core, or none do, never leaving any traces behind, even if aborted, thus preventing system leakage. This is something really important on Linux distributions, since quite a few users forced down the computers in the middle of an upgrade. So this could be disastrous if, say, you have tons of GBs of updates. You're updating your display manager, bootloader, your kernel, all of that, and you just interrupt it. And while apt, for example, does take measures to prevent that, it doesn't allow seconds, for example, control Cs. You can always force it down the computer and just check your whole system. So atomicity is something important on such systems, since it prevents system leakage. Coming to the issues with Linux distributions. That is, yep, so I'll just go to the next slide. If you have an ounce of familiarity with the chhatter command on Linux, you'll know about the existence of file attributes that are particularly helpful when you'd like to restrict the behavior of a file. You have the I bit, for example, that makes a file immutable. Consequently, it paves the way for an immutable user tree. This is what we use for the first release of CentOS v1 that will iteratively and recursively set the I bit on files under the USJ on parallel using all of the CPU threads available during boot. While it does technically serve the purpose of having an immutable system, it conversely does not allow for atomic updates without having to unset the bit on all of the system files, and was also quite slow, which I see as an absolute win. To be precise, yep. You do not want to have to disable immutability to be able to update your system. That is simply bad design. Let's come to overlays, or overlay FS to be precise. Overlays are a feature of the Linux kernel that allow for one file system or bind-mounted directory to be overlaid over another, with a lower directory and an upper directory. Any writes are redirected to the former if the overlay mount, to the latter, the upper directory, if the overlay mount hasn't been made read-only, something I'll come to later. This allows us to have the base system read-only while still allowing for the installation of packages. For example, you could simply mount the upper directory to another mount point, and you could install packages to that and expect them to be applied. However, this isn't officially mentioned in the documentation, and is known to result in unpredictable behavior, especially if you modify the base directory as well, or the lower directory, which in our case is the user directory /user. For this reason, v2, the second release of CentOS, would install updates for the base system that were intended for the base system, regular Arch package updates, to the overlay instead, resulting in the base system never being touched after installation. It was effectively fruitless. Another disadvantage comes in when you realize that people could simply, mount the overlay somewhere else as a read-write directory and modify the system, break it all, and yep. However, BlenderOS v3 changes this. We made a bunch of changes including not mounting the overlay as read-only, the user overlay to as read-only, besides not allowing any modifications to the base system, of course, and we now have a tool for installing system packages to the user directory if you really need to. We still go to the overlay, of course, and these overlays are rebuilt on updates. For Atomicity, we simply replace the base system on the next boot and rebuild all of the overlays based on the new lower directory, thus not resulting in any issues that I previously discussed. So this effectively discards the pedal of system breakage. Speaking of atomic mannerisms, how about we discuss the implementation of atomic updates in BlenderOS v3? Initially, we were playing around with OST. It is something used by Fedora Silverblue, UBlue, and quite a few other Linux distributions, while also known for long update times. It is quite complex, and we decided not to go for it in the end, since first of all, it had never been messed around with in Arch, so it simply made no sense for us to port it to write a whole utility for it in Arch, or use the libOSC library for this purpose, or the OSC library now, since it was renamed to OSC the library as well. Then another thing would be we use ISO for updates. Unlike other immutable distributions that usually use binary blobs or even containers, for example, Crystal Linux was working on an implementation of this sort. Or to be precise, one of the team members, they were working on an implementation where they use Flatpaks for system updates. Here, however, we use csync to pull updates. So before your keyboard warriors, watching this talk online, go into a comment typing frenzy. Yeah, we use csync, or to be precise, a fork of csync 2, maintained by the app image community on GitHub, to reduce the size of updates from several gigabytes to a few dozens of megabytes in the double digits, since at the moment, most of the BlenderOS ISOs are sized above 2 GBs or 2.5 GBs, in comparison to other distributions, especially those based on Arch, that are, hardly a single GB. We're not talking about Ubuntu here, of course, but yep. This is caused by RAID, which we use for Android apps, since the system image itself is of around 900 MBs, but yep. BlenderOS periodically checks for any new ISOs that might have been released. We use our own daemon, known as Akshar, which checks for ISOs periodically and pulls them using csync 2, if all of the requirements have been met. That is, there's sufficient disk space, you're connected to a network, and everything else. It then installs the ISO to its own directory on the root file system. So this is just like a regular installation, since BlenderOS is immutable, and thus you can't make any changes to the file system aside from installing any new system packages or removing them. So you might be wondering how we handle system packages if we're installing an ISO and we're replacing our current file system with it. Since you would expect all of the custom installed packages to simply get wiped away on such an update. So remember the bit about overlays earlier? Well, we build these overlays, so we use the current lower directory and we create new overlays using the existing system packages during updates. And yep, so those are overlaid on the next boot on top of the new file system. Speaking of how we swap these file systems out, on the next boot, we use an init hook, an mkinit CPIO hook. We do have plans to migrate to Zakat, but not for the next release or even the next one. So yep, that's gonna be in the future, in the far future. So an mkinit CPIO hook is used for this purpose, which renames the current user directory, replaces it with a new one, and also any etc directories that may have any files under etc that may have changed in the new file system. And yep, so this takes just as much time as a regular rename syscall would, a total of 0 seconds, so the core time of 0 seconds, since it doesn't take any time, as you'd probably know if you use Linux. So in the end, after an update, you have multiple reboots. So it essentially replaces your current user directory with a new one. That is the first stage. Once that is done, it just in case to ensure there aren't just to ensure a force shutdown doesn't break your system, since that's what we're trying to combat here. We have a few state files that indicate an ongoing update. So if on the next boot, if you force shut down your computer and you boot it on and you boot it again, it will know the init hook would know about a pending update or an in progress one, and thus continue with it or abandon it if such a situation arises, though it probably won't. Then etc, however, doesn't involve a simple rename because we have to check for what files have been changed and what haven't. Since you might have changed your default shell, for example, or you might have created a few new users, or all of that. So we check for any changed etc files, and contrary to how Arch Linux deals with them, our base distribution is Arch Linux. CentOS that keeps your current package file. Actually, I think this was changed in Arch Linux as well. They keep your changed package file now. So simple pack new file is created. But here, we just keep the existing file, and yep, all of the files that you may not have changed are replaced, of course. As for how we implement support for multiple Linux distributions, we use Podman containers for this purpose. So also we have a simple Plenary settings app, so you can just create a container. Plenary automatically uses unnotified hooks for this purpose, so it checks if any new file has been created, if any new binaries or packages have been created. It then exports them to a directory on the file system. So you have essential aliases so you have aliases in the format of name of the binary on the container dot name of the container. So you can just run that command from a terminal to use any commands you install inside the terminal. So you could just open the Plenary settings app. You could create an Ubuntu container, for example. If you say want to use tools like Bazaar, BZR, which was quite popular on VCS tool, used as an alternative to Git and employed by Ubuntu from around 2014. It was deprecated around 2017. I mean, it is still in use, but Launchpad and other platforms no longer use it. However, for the sake of an example, if say you want to use Bazaar, you could simply install it from the Ubuntu repositories, and you'd find it on your host system as bazaar.ubuntu, or bcr.ubuntu. So you could simply execute it from your host terminal. And then, of course, if you don't want to have to run bcr.terminal every single time, we have associations where you can associate a particular binary like bcr to an Ubuntu container. So whenever you run bcr, say, it will automatically use the command from the Ubuntu container. Coming to GUI apps, then, any GUI apps, similarly, we use iNotify for this purpose, iNotify hooks. And any GUI applications are exported and they appear in your app launcher. So there we have it. An easy-to-use system that never breaks and stays up to date. If you have any questions, feel free to ask me now, since we have a whole 8 minutes to go.
You need to take this.
Anyone has any questions?
It's okay.
Anyone has any question? Yes.
Hi, so is Windows publicly available? Can we download it?
Yep. Okay, then. Let's download it. I can't exactly hear you, but for the first question, you can download it from Blender. That's the website.
Is there a link?
Yes. Just open Blender. I'll share it in the chat. You all can see it, but yeah, hopefully the organizers can make it clear. I'll send it in the chat. Have a chat for the organizers. Blender's of course, so yep.
Apart from that, with games, do we have a community for Windows?
Sorry?
Do we have a community which maintains Windows, or you are the sole maintainer?
Yep. So at the moment I'm the sole developer. But we do have quite a few moderators. And yeah, I'm the only developer and project lead. So.
Any other questions? Any external questions? So, Udra, thank you very much for your nice talk, and that we could that you could make it at least here to participate remotely from Kochi, and we will see us in a few days in person. And so I hope that everyone has now a nice insight into immutable distros from two sides, from Blendvoice and from Ubuntu Desktop. And now we are at the end of our opportunity open source. I hope everyone liked it and that everyone has made a nice experience and learned a lot. Thank you very much. And so I hope that sooner or later we can perhaps do it again with more time for planning, with more people on the organization of the Mandi. And also I want to thank first of all Canonical. They are an amazing employer. They gave me the liberty to do a lot of community work, to not only participate in the organization of the Ubuntu Summit and other conferences, but also to completely create this conference, to not only pay my travel expenses, but also to give me the e-core, to give me the StreamYard, so that we have all the infrastructure to do a modern conference. And so I want to say thanks a lot to Canonical, and also to the help of Canonical's community team to help me getting started with all the infrastructure and to learn how StreamYard works and so on. And also to give me all the motivation. And also I want to thank the IIT Mandi to supply this nice venue to me, and Akanshan for doing the organization on location. To find volunteers to help me on the AB. And then I also want to thank for everyone who received me when I arrived from the long road trip from Delhi to here at 2 a.m. and they stayed awake to receive me when I arrived. It was really great. It was amazing from you. Thank you very much.
I guess there is a question for Rudra. I'm sorry for
Yes.
Can you give it to me?
Yes.
Rudra, do you want to come back?
So, this is a question.
We got a question a little bit late.
Oh, Rudra, let's remember. Okay, we can mention it there.
You can mention it later.
I'm sorry, there are two questions for Rudra, but we couldn't answer that.
But Rudra has already left.
Yeah.
So perhaps you pass them on to me by email or so, because I can ask
you. Can remove this. Yeah, you can remove this and ask this question.
So the stream is still running. I can say a goodbye to the spectators.
Before you leave, I have to
Yes. Yes, and also now as we are now on the conference for the remote attendees who have attended our conference via YouTube or via Twitch. We will in a few minutes stop our streaming. I want to say goodbye and thank you for participating. And also thank you for anyone who has asked the question remotely. Unfortunately now, Rudra has already left, but I will pass on the question to Rudra when I'm in Kochi next week, because there we will meet in person. And so I will pass on to Avik now.
Thank you, Dave. So first of all, thank you everyone. Thank you everyone for joining the session. But before we leave for the day, I wanted to thank few people. First of all, Akarshan and IIT Mandi, and the volunteers, of course. I do not have the full list of the names of everyone, but few names as I can remember, like Gagan, Uday, Vishwadeep, so a couple of them. I mean, I do not. I'm sorry, I do not know or do not remember all of your names. But there were a couple of people who have been helping, from 2 a.m. in the night on Friday. We landed up in your campus at 2 a.m. in the night, and people were there to receive us till now. The support and the hospitality that you have been showing, it's commendable. So thanks for all that. And also,
like to take the opportunity to thank few people like without whom we converted a student meetup to a conference. Like yes, there were technical glitches, but it happens. So this was our first time organizing something of that this sort here. So thanks to Jonas and Susan for sending the real boards all the way from Germany and for sending the ST boards as well. So thanks to FITech. Susan has been working a lot on the background, in helping us coordinating couple of stuffs, especially with respect to Zephyr, requesting people like Susan and requesting people like Oliver and others to give a talk. Oliver, Suha, all this journalists, etc. So Susan has been working a lot on that. Kate Stewart wanted to be, she would have loved to be with all of you, but I requested her, since she was not able to join physically, I requested her to send us a recorded talk. Thanks to Kate for sending that recorded talk. Thanks to all the speakers, Jonas, Oliver, Rudra, Ritik, everyone who has joined us online. Thanks to the Canonical gang for joining us here. It was a nice experience. And thanks to Benjamin as well for his talk on Zephyr. And last but not the least, thanks to Brett for sending some nice Zephyr kites all the way from San Francisco. So if you want to fly those kites, those are with Akarshan. I'm not sure if people have already started flying it, but it's a different kind of kite altogether. What you are seeing with the Zephyr logo. So you need to build it, and it's made of plastic, so it's reusable. It's not a paper kite that you fly it and then it goes away. So you can reuse it. So yeah, and whoever I might have missed, it was not intentional. So again, thanks everyone, and thanks to Till for coming all the way from Vienna to the campus for this conference. Before I requested him. He was supposed to travel to DEFCON. So I requested him. I said let's have a student meetup in IIT Mandi, and then it all got converted into a conference. So thanks for that. Thank you everyone.
So you were really the people who made my first trip to India an awesome and amazing trip. Who made my first trip to India an awesome and amazing trip. You were all great as speakers, as volunteers. Thank you very much again. Here to Mandi. And I hope we will soon have also a local community in India for Ubuntu. I've made a lot of QR code scans. If you fill in all the form, then we will get a nice team. And so, thank you very much for everything. No, it's okay, it's okay.
I think we can close this here now.
Yes. So we can stop.
Yeah, I have a request first core team to come forward, then rest of the volunteers to occupy the backstage. Rest of the people to occupy the backstage. Sir, we'll have a group photo.
Yes. And I also want to say thank you to the Indian governments, as the roads from Delhi to here were really great. It was really nice to do this trip by car. I was fearing that it could be really bumpy.